The notion that an object from outside our stellar neighborhood could be drawn here, rather than merely drifting through the vast expanse of the cosmos, sounds like a premise plucked directly from a science fiction screenplay. However, with the appearance of 3 Atlas, certain astronomers and theoreticians began to observe peculiar convergences that defied simple random chance. The network of telescopes that initially detected this visitor did so on the first day of July 2025, a date that, while appearing ordinary on the calendar, held a peculiar significance within astronomical observation schedules. This marked the exact midpoint of several major celestial survey endeavors. For some, this timing was cause for raised eyebrows. Why would the third confirmed visitor from beyond our solar system in recorded human history materialize precisely when our observational capabilities were at their zenith? Could it be mere serendipity, or were circumstances subtly arranged to ensure its detection? The concept of summoning in the context of astronomy does not allude to occult practices or supernatural intervention. Instead, it implies a degree of intentionality, a process wherein something is guided or attracted, rather than arriving by accident. Had 3 Atlas traversed the galaxy for eons, its arrival in our planetary vicinity, at this particular juncture, under such intense human scrutiny, might seem less like happenstance and more like deliberate placement. Within the realm of celestial mechanics, it still adheres to the fundamental laws of gravity and momentum. Yet, in the speculative sphere, it could represent something akin to a response to an unseen signal, an answer delivered across immeasurable gulfs of space. The initial quandary to address is whether the concept of summoning even holds validity on interstellar scales. To direct an object across distances measured in light years would necessitate not only immense energy, but also a level of precision far beyond our current technological comprehension. Nevertheless, objects exhibiting hyperbolic trajectories do not always behave as if they are mere accidental ejecta. Some display velocities or approach vectors that appear less like the statistical scatter observed among billions of comets, and more like deliberate entries into specific cosmic locales. 3 Atlas hurtling inward at a speed exceeding 130,000 miles per hour traced precisely such a path, slicing through our solar system on a trajectory that guaranteed its visibility from Earth at a moment when it could not be overlooked. The confluence of factors was too striking to simply disregard. Skeptics contend that the universe is immensely large, populated by countless errant bodies, and that the appearance of one during a period of heightened astronomical readiness is statistically inevitable. While this may hold true, from a probabilistic standpoint, the critical question becomes not whether it could happen, but whether it would occur precisely now, in this exact configuration, with this specific assemblage of chemical signatures and orbital characteristics. Probability has a curious way of raising red flags when the improbable accumulates repeatedly. 3 Atlas represented the third interstellar visitor encountered within a mere 8 years. This cluster suggests either a significant enhancement in our detection capabilities or something more profound regarding the cadence of these arrivals. Theories of summoning do not posit that humanity actively reached out and physically pulled a celestial body across space. Instead, they center on the possibility that signals, whether intended or unintentional, acted as attractors. For over a century, Earth has been emitting radio waves, inadvertently leaking television broadcasts, and more recently, powerful radar pulses that propagate far into interstellar space. These transmissions have formed an expanding sphere, now exceeding 100 light-years in diameter. If a civilization were to exist within this sphere and possess the means to manipulate interstellar detritus, it could, in theory, direct one of these objects toward us. The motivation could range from communication and reconnaissance to something far more enigmatic. However, the mechanism would appear to us as mere coincidence, masked by natural physical processes. When astronomers initially confirmed 3 Atlas's hyperbolic orbit, the prevailing explanation aligned perfectly with its ejection from a distant star system billions of years prior. However, summoning theorists posed a different inquiry. Why now? Why this specific century of human technological advancement? Why at the precise moment our instruments possess the sensitivity not only to detect it, but to meticulously analyze its chemical composition? The suspicion arises not from a violation of physical laws, but from the timing. An object traveling at such speeds could not alter its course mid-journey, but it could have been propelled or nudged at precisely the opportune epoch to arrive here when humanity was equipped to notice it. In this interpretation, summoning is less about physical pulling and more about carefully timed scheduling. Historical parallels emerge when we consider how frequently discoveries coincide with humanity's possession of the necessary tools for their observation. Quasars, pulsars, gamma ray bursts all remained invisible until technology advanced to the point where their faint signals could be captured. However, unlike these phenomena, which are distributed uniformly throughout the cosmos, interstellar objects physically traverse our solar system. They interact with sunlight, radiate heat, form comas, and in rare instances, pass close enough for detailed observation. Their arrival feels more personal, less like random background noise, and more akin to a deliberate knock upon the cosmic door. The unique chemical composition of 3 Atlas further deepens this enigma. Upon examining its coma with the James Webb Space Telescope, astronomers detected a dominance of carbon dioxide, a characteristic unlike any comet ever observed. The ratio was so extreme that while natural explanations remain possible, they strain credulity. Theories of summoning incorporate this chemical anomaly into their framework. Perhaps the signature was intentionally designed to be conspicuous, to appear sufficiently unusual that human astronomers would not dismiss it as commonplace. In this perspective, the object served as both a messenger and the message itself, a piece of extraterrestrial geology bearing a calling card encoded in its very chemistry. The mechanics of such summoning challenge our imagination. To eject a comet from a star system requires gravitational interactions of immense magnitude, typically involving giant planets flinging smaller bodies outward. For this process to be engineered, an intelligence would need to command planetary-scale dynamics, possessing the ability to orchestrate gravitational slingshots with a precision capable of dispatching an object across interstellar voids for billions of years. To us, such control appears indistinguishable from fantasy. Yet, it prompts the disquieting question: if it were feasible, would we even recognize the evidence of its manipulation? From our vantage point, it would still present as a natural hyperbolic trajectory. The disguise would be flawless. Another layer enters the discussion when we consider the timing within a broader cultural context. Humanity's civilization has only recently embarked upon its spacefaring era. Within a single century, we have progressed from our first flights to deploying probes across planets, from discovering radio waves to establishing a global internet. Had 3 Atlas passed by in the year 1025 instead of 2025, it would have remained invisible to us, merely another celestial wanderer in the night sky. Its arrival at this precise moment, when humanity possesses the capability to both detect and globally analyze such an object, feels suspiciously opportune. This alignment of readiness and arrival forms the core evidence fueling summoning speculation. Critics counter that this perspective is anthropocentric, arguing that the universe does not orchestrate its events around human capabilities. However, the counter-argument circles back to coincidence. If interstellar wanderers are a common occurrence, why did we detect none before 2017 and then suddenly 3 within a decade? The most apparent explanation is improved observational technology. Yet, the unsettling alternative is that something has shifted within the cosmic environment, or worse, that something has begun dispatching them intentionally. 3 occurrences in rapid succession may not definitively prove design, but it provides a sufficient pattern to sustain speculative inquiry. If summoning indeed occurred, what might its methodology have been? One possibility involves not the direct manipulation of comets, but rather subtle adjustments employing directed energy beams. Powerful energy systems could, in theory, impart minute nudges to an object over immense timescales, altering its trajectory until it intersected with our solar system. Each nudge would be imperceptible from Earth, but their cumulative effect over millions of years could be profound. Another potential scenario involves seeding star systems with dormant probes disguised as natural celestial bodies, programmed to activate their inward trajectories only upon detecting the electromagnetic emanations of a nascent civilization. In such a case, 3 Atlas was not summoned from afar. It was waiting in proximity, triggered by our presence, awakened rather than drawn. The silence of radio telescopes complicates this theory. If the object were genuinely a summoned probe, one might anticipate the detection of discernible signals. Yet, surveys have reported nothing beyond natural cosmic emissions. This absence either undermines the theory, or depending on one's viewpoint, reinforces it. Perhaps the intelligence behind the object is so advanced that it completely evades detection, blending seamlessly with background noise. Or perhaps it is deliberately silent, observing without revealing itself. In either instance, the lack of direct evidence becomes a form of evidence in itself, fueling the suspicion that something more deliberate is unfolding. Public reaction to these notions has been varied. For many, the concept of summoning smacks of conspiracy, a desperate attempt to impose meaning where none inherently exists. For others, it resonates with deeply ingrained intuitions about humanity's place within the cosmos. Ancient cultures frequently interpreted comets as omens, divine messages, or harbingers of significant change. In a peculiar way, summoning theories echo these ancient intuitions, translating mythological concepts into the language of speculative astrophysics. The comet is no longer perceived as a divine message, but perhaps as a technological one. The implications of summoning ripple outward. If 3 Atlas was directed here, it suggests the presence of an entity aware of us. It might be monitoring, testing, or simply curious, This reframes the object from inert, geological matter to an active communicator. The very idea destabilizes the comforting framework of astronomy as a discipline concerned with inanimate substances. Suddenly, trajectories and compositions might possess intent, and intent implies intelligence. The leap from the natural to the artificial is substantial, but once contemplated, it becomes difficult to dismiss. The genuine challenge lies in the realm of evidence. Summoning theories thrive on meticulously timed coincidences and observed anomalies, but without concrete proof, they remain within the domain of speculation. Yet, speculation itself possesses value. It broadens the scope of the questions we pose, the scenarios we investigate, and the patterns we seek. If nothing else, the possibility of summoning compels astronomers to confront the limitations of their presuppositions, to recognize that the absence of expected explanations might point towards something we have yet to conceive. The narrative continues to unfold with each subsequent observation. As 3 Atlas approaches its closest point to the Sun, instruments worldwide are measuring shifts in its activity. If these shifts exhibit patterns inconsistent with natural solar heating, suspicion will intensify. If they reveal nothing beyond typical cometary behavior, the natural explanation will gain further credence. Regardless, the object has already served a crucial function. It has compelled humanity to ponder whether visitors from beyond are random occurrences or responsive entities, whether the universe occasionally answers without our explicit invitation, and whether we are being noticed. And as telescopes track its diminishing coma, in the months following its closest approach, the fundamental question will endure: was 3 Atlas merely another cosmic wanderer, or was its appearance part of something grander, something that links human observation, cosmic timing, and the profound possibility that we are not merely observing the universe, but are, in turn, being observed? The question of timing lies at the very core of this debate. When an interstellar object arrives, we can precisely calculate its velocity, its trajectory, and the point of its closest approach. However, we cannot definitively calculate the reason for its arrival at that specific moment. For 3 Atlas, the mathematical data itself is straightforward. It possesses a hyperbolic orbit, an excess velocity exceeding 60 kilometers per second, and its closest passage to the Sun is projected for late October 2025. These figures unequivocally confirm that it is not gravitationally bound to our Sun. It will transit through and then continue its outward journey into the galaxy. The mathematics offers little room for ambiguity. Yet, the human mind resists settling solely for orbital mechanics when coincidences in timing appear too striking to ignore. The distinction between cosmic timing and a cosmic call is subtle yet significant. One represents the rhythm of random physical processes. The other implies intentional design. When the first confirmed interstellar object was detected in 2017, it was named Oumuamua and carried the mystery of an unfamiliar shape. Observational data was scarce, debates were fervent, and ultimately, most astronomers classified it as a natural, albeit unusual, phenomenon. 2 years later, Borisov arrived, appearing much more like a conventional comet, which diminished speculative theories. At that juncture, interstellar objects were still regarded as rare statistical anomalies. The anticipated rate of discovery was at best once per decade. Yet, a mere few years later, In 2025, a third object appeared, traveling faster than the previous two, exhibiting a larger apparent coma, and possessing a more peculiar chemical composition than either. This cluster of detections demanded an explanation. Were we simply becoming more adept observers, or was something else at play? If cosmic timing alone is the responsible factor, the answer lies in probability and advancements in technology. Sky surveys have expanded dramatically, with automated telescopes scanning the heavens nightly. The Vera C. Rubin Observatory is poised to discover many more such objects, suggesting that we have always been surrounded by these wanderers, but remained oblivious until now. In this sense, the timing is natural, a direct result of human progress in our observational instrumentation. However, the counterargument remains unsettling. If these objects are so common, why have their arrivals clustered so tightly within human historical time? Why did none reveal themselves earlier, when comets were observed for centuries by diligent astronomers utilizing telescopes capable of detecting faint objects? The universe does not owe us convenient timing. And yet, here they are, appearing in sequence, as if awaiting our readiness. The concept of a cosmic call suggests not coincidence, but deliberate choreography. In this interpretation, the universe itself might not be random, but responsive. A civilization capable of manipulating objects on interstellar scales could utilize them as messengers, dispatching them along pre-calculated paths designed to intersect with other civilizations at precise epochs. The margin for error in such an endeavor would be immense, requiring predictive capabilities for planetary positions, stellar motions, and even the technological maturity of the receiving species. But if mastery over gravity, energy, and information had been achieved by an entity far older and more advanced than us, then timing would not represent an obstacle. It would be an integral feature. The object would arrive not when it chanced to wander by, but when it was intended to arrive. This speculation thrives on a confluence of coincidences that are too numerous to dismiss. The date of discovery, July 1st, 2025, places it almost exactly between previous interstellar detections and anticipated future survey expansions. It arrived at a moment when both the Hubble and James Webb telescopes were fully operational, when ground-based observatories across multiple continents were interconnected via data-sharing networks, and when artificial intelligence could process survey results in near real time. In essence, it arrived during the first period in human history when a truly global observational infrastructure was in place. The object was not merely visible, it was unmissable. If this is timing, it is remarkably uncanny. If this is a call, it is deliberate. Skeptics emphasize the perils of hindsight bias. Once an object is discovered, humans are adept at constructing narratives around its timing. Any date can be made to appear significant if appropriately framed. Perhaps July 1st is irrelevant. Perhaps the cluster of discoveries reflects nothing more than the exponential growth of sky surveys. And yet, the sense of unease persists. Astronomers themselves acknowledge that had this object arrived 50 years earlier, we would not have detected it. And if it had arrived 200 years earlier, it would have passed entirely unnoticed. The fact that it should appear now, within this narrow temporal window of human technological advancement, feels difficult to dismiss as mere coincidence. The comparison with other cosmic events is instructive. Supernovae, gamma ray bursts, and gravitational wave detections all occur independently of our observational readiness. We only perceive them once our instruments achieve the necessary capability. However, those signals can often be detected retroactively in archival data. Interstellar objects do not afford us that luxury. They arrive and depart once, leaving only a brief window for observation. Their timing is not simply coincidental, it is decisive. A missed detection is permanent. That 3 Atlas was detected during the narrow window, when humanity was capable of responding globally, feels like more than just serendipity. The idea of a cosmic call raises further questions. If such objects are being deliberately sent, what is the mechanism of this summoning? Is it a response to our electromagnetic leakage, the radio and television signals that began broadcasting into space a century ago? If so, the timeline does not align neatly, because the object's journey likely commenced billions of years ago. No signal from Earth could have reached its point of origin in time to trigger its launch. This implies that the call, if it exists, was not initiated by us, but by something else entirely. Perhaps it was an ancient trigger embedded within the very physics of the galaxy itself. Or perhaps it represents a coordinated effort among civilizations far older than our own. Or perhaps we misunderstand the very nature of being summoned. An alternative interpretation suggests that the object was always present, one of countless celestial wanderers, but that our own actions drew attention to it. This would not be a summoning across space, but a summoning through perception. By developing instruments capable of noticing, by expanding the sphere of our awareness, we effectively called it into our reality. In this sense, cosmic timing and cosmic calling are not opposing forces, but complementary ones. The object was always there, but it only became meaningful when we were prepared to perceive it. The act of observation itself serves as the summons, collapsing mere possibility into tangible reality. There is also the disquieting notion that timing may be intentional in a way that tests rather than communicates. If an intelligence sought to measure the progress of a young civilization, one method would be to dispatch a series of progressively more unusual objects and observe the species' response. For instance, Oumuamua to test detection capabilities, Borisov to confirm classification, and Atlas to challenge chemical understanding. Each object, more complex than the last, would serve as a calibration of our readiness. The timing in this context would be evidence not of randomness, but of pedagogy. As if the galaxy itself were a classroom, and humanity had only just begun to acknowledge the lessons. The concept of a cosmic call also resonates deeply with ancient myths and cultural narratives. Human history is replete with accounts of celestial omens, signs that appear at moments of profound change. Comets have been blamed for plagues, celebrated as heralds of royal successions, and feared as harbingers of doom. The fundamental difference today is that our culture translates these omens into quantifiable data, yet the psychological resonance remains. When something unusual appears precisely at the moment we are most equipped to perceive it, we are instinctively drawn to interpret it as meaningful. The distinction between mere timing and a deliberate call blurs because, from a human perspective, coincidence itself can feel like communication. If the object was summoned, whether intentionally or not, the next question that arises is, why? What purpose does such precise timing serve? Some argue it represents contact in its most gentle form, a method of announcing presence without risk, a low-stakes introduction across vast cosmic distances. Others fear it could be reconnaissance, a probe disguised as natural geology, assessing our readiness for something more significant. Still others frame it as neutral, a simple delivery of extraterrestrial chemistry intended to broaden our understanding of what worlds beyond our solar system can produce. Each interpretation relies less on empirical data and more on philosophical outlook, on how one interprets the significance of timing. As the cosmic entity draws nearer its closest proximity, celestial observers will continue to sharpen their estimations. The nebulous envelope's dynamism, the core's dimension, the gas expulsion proportions, all these shall be meticulously recorded. None of these figures will directly resolve the enigma of chronology. That remains perpetually beyond the grasp of our instruments. Yet, it will persist within the realm of human invention, conjecture, and perhaps innate knowing. For whether one perceives it as a temporal alignment or a summons, the incontrovertible truth is that three Atlas entities materialized at this juncture, not preceding, not subsequent, but precisely now, when humankind was receptive to observation. And that sheer synchronicity alone guarantees the question will endure. The discourse will persist not solely amongst the scientific fraternity, but reverberate throughout the broader cultural landscape. Every peculiar revelation henceforth will be evaluated against the benchmark established by these initial three interplanetary travelers. Each will reintroduce the query anew. Is this a matter of celestial timing or a cosmic beckoning? The advent of three Atlas beings would be remarkable in itself. But the genuine disquiet commences when we withdraw and scrutinize the succession as a unified whole. Within the span of a single human existence, three authenticated interstellar bodies have traversed our solar system. Prior to the year 2017, none were detected. For eras, astronomers meticulously charted comets, asteroids, and objects near Earth. Nevertheless, none bore the indisputable hallmark of a hyperbolic course originating from beyond our solar vicinity. Then, with suddenness within a confined interval, the configuration emerged. One followed by another, and then a third, each distinct in its attributes, yet unified by its origin. It is this clustering that fuels the suspicion of deliberate orchestration. The inaugural Oumuamua arrived as an unexpected phenomenon. Its elongated form, rapid rotation, and inexplicable velocity increase compelled astronomers to scramble for rationalizations. The subsequent Borisov presented a more familiar guise, exhibiting the unmistakable coma of a comet, yet traversing an interstellar trajectory. It offered solace to those who favored naturalistic explanations, reminding us that extraterrestrial visitors might bear resemblances to what we already comprehend. The third entity, Atlas, once again complicates the scenario with its velocity, magnitude, and chemical composition that defy conventional classifications. The sequence itself evokes a sense of progression, uncertainty, reassurance, and a renewed challenge. Configurations are what the human intellect instinctively seeks, and this particular arrangement is arduous to disregard. If these arrivals are indeed fortuitous, then we ought to anticipate their distribution across centuries, perhaps millennia. The solar system is vast, our capacity for observation limited, and the galaxy teems with countless entities drifting without apparent purpose. That 3 of them materialized in rapid succession during the early 21st century is improbable, though not beyond the realm of possibility. Statistical deviations do occur. Nevertheless, the timing feels like more than mere happenstance. Patterns emerge not only in their spacing, but in their intensification. Each entity appears to be calibrated to elevate the level of speculation incrementally, to incite deliberation without offering definitive answers. One method to ascertain whether the pattern is actual or illusory is to contemplate the potential for discovery. Technological advancements account for a portion of this. The Pan-STARRS telescope, which first observed Oumuamua, was among the initial instruments systematically surveying the heavens with a sensitivity capable of detecting such faint, swiftly moving objects. The detection of Borisov was facilitated by increasing global cooperation. An atlas was apprehended by a network based in Chile, optimized for broad field surveys. Enhanced observational tools yield greater discoveries. The configuration, assert skeptics, is simply the natural outcome of evolving capabilities. Had the Vera Rubin Observatory been operational in preceding centuries, perhaps dozens would have already been cataloged. However, this line of reasoning fails to address the more nuanced pattern, the escalating strangeness of the arrivals. Technology can elucidate numbers, but it cannot account for narrative intensification. The escalation suggests a calculated progression. Initially, an anomaly to capture attention. Subsequently, a familiar entity to alleviate anxieties. Finally, one that amalgamates both, simultaneously reassuringly cometary, and disconcertingly alien in its chemistry and velocity. If these were stages in a controlled experiment, one could hardly devise a more effective script. Each event builds upon the preceding one, creating a rhythm that feels deliberately orchestrated. Whether born of natural coincidence or intentional design, the pattern is undeniable. The chemical signatures introduce an additional facet. Oumuamua exhibited no discernible coma, sparking conjecture about whether it was rocky, metallic, or artificial in nature. Borisov followed with a composition that appeared reassuringly ordinary, akin to comets originating from our own system. Atlas, however, defied expectations with its overwhelming dominance of carbon dioxide, a proportion so extreme that it does not align with any known solar system object. Here, once again, the pattern manifests: absence, normality, excess. Each stage compels astronomers to revise their hypotheses, preventing complacency. The pattern is not confined to temporal aspects, but extends to content. Each entity expands the parameters of what an interstellar visitor can be. If we entertain the hypothesis of summoning, then patterns assume paramount importance as evidence. No intelligent civilization would expend resources dispatching random debris devoid of purpose. If interstellar objects serve as emissaries, then variations in their form and chemical makeup could function as signals. A sequence of 3, each possessing distinctive characteristics, might represent the initial notes of a more extensive communication. Not a language in the human vernacular, but a language of materials, orbital paths, and temporal sequencing. The first conveying observe, the second comprehend, the third inquire. The subsequent might articulate something more. Yet, even within naturalistic frameworks, patterns necessitate explanation. Models of planetary formation predict that star systems eject substantial quantities of comets during their nascent phases. These bodies traverse vast distances for eons and eventually intersect with other stellar entities. If this is the case, then interstellar visitors should represent a broad spectrum of types and chemical compositions. Nevertheless, our initial three examples do not scatter randomly across categories. They align in a manner that appears intentional. Why should the very first detected lack a coma, the second display a textbook coma, and the third present chemical anomalies unprecedented in our system? Why not three ordinary comets consecutively? Why not three rocky asteroids? The pattern resists simplification. It is conceivable, of course, that this sequence signifies nothing more than a bias inherent in a limited sample size. With only three instances, any combination will appear suspect. Perhaps, as we detect dozens or even hundreds more, the anomalies will recede into the background noise of statistical fluctuations. However, until such a more extensive sample becomes available, the pattern remains striking. Humanity's introduction to interplanetary visitors has unfolded as though crafted to elicit maximum curiosity. The escalation, the variability, the clustering. They coalesce into a pattern that invites speculation as to whether we are witnesses to randomness or participants in something more substantial. Consider also the geographical distribution of detections. Oumuamua was discovered in Hawaii, Borisov by a Crimean amateur astronomer, and Atlas in Chile. Three distinct latitudes, three disparate cultural contexts, yet all within nations actively engaged in space exploration. No single observatory monopolized the discoveries. Instead, the pattern dispersed the events globally, ensuring widespread attention and swift verification. If one aimed to maximize global awareness, one could scarcely devise a superior strategy. Randomness offers an explanation for distribution, but design accounts for engagement. The pattern ensures the entire planet is attentive. Another dimension emerges in the pattern of velocities. Each interstellar visitor has demonstrated an increasing speed compared to its predecessor. Oumuamua at approximately 26 kilometers per second, Borisov near 32, and Atlas exceeding 61. The escalation is stark. If random, it might reflect nothing more than the range of velocities common among ejected celestial bodies. But if intentional, it could signify a testing of limitations. How swiftly an object can arrive and still be observed, analyzed, and debated by human astronomers. Each one pushes the boundary further, challenging both instruments and theoretical frameworks. The pattern is not merely one of appearance, but of stress testing. Patterns also manifest in public perception. The first ignited wild speculation concerning extraterrestrial technology. The second allayed those fears by exhibiting predictable behavior. The third reignited the debate by juxtaposing natural appearance with unnatural chemistry. This emotional cadence mirrors the scientific rhythm: surprise, reassurance, and renewed enigma. Patterns are discernible not only in the data, but also in the reactions, as though the events are engineered to manage human responses. Whether by design or by chance, the pattern functions effectively. It sustains attention without tipping into widespread panic. Skeptics caution that humans are inherently pattern-seeking creatures, inclined to connect dots even in their absence. This is accurate, yet in the realm of science, pattern recognition often serves as the initial step toward discovery. Quasars were once dismissed as mere noise, until their regularity unveiled a novel class of celestial body. Pulsars were initially suspected of artificial origin until their consistent timing proved to be natural. Patterns can mislead, but they can also revolutionize. The pertinent question is whether the configurations of interstellar arrivals fall into the former category or the latter. The broader implication is sobering. If the pattern is genuine and deliberate, then humanity has already entered into a dialogue without its full realization. This dialogue may not employ words, but rather sequences of celestial bodies, each conveying a message through its form, chemistry, and timing. The progression implies a plan, and plans presuppose planners. If that is the case, then subsequent arrivals will be of critical importance. They may corroborate the pattern or dismantle it. They may elevate speculation to conviction or reduce it to mere coincidence. In either scenario, the pattern has already fundamentally altered our perception of the cosmos. As telescopic surveys continue, astronomers now anticipate observing a greater number of interstellar entities. The Vera Rubin Observatory will likely identify several annually. If those arrivals disperse randomly across categories, the pattern will diminish. However, if they continue to escalate in velocity, magnitude, or anomaly, then suspicion will solidify. Each new detection will be weighed against the initial three, each meticulously analyzed to determine if it integrates into an emerging sequence. The pattern will either dissolve into background noise or sharpen into a discernible signal. The ensuing decade will provide the answer. Until then, the initial three arrivals constitute a narrative that cannot be disregarded. A narrative of coincidence that feels like choreographed movement, of anomalies that accumulate into a discernible progression, of a universe that may be less random than we assume. Whether the pattern reflects natural diversity or deliberate design, it has already achieved its intended effect. Humanity is observing more intently, posing deeper inquiries, and contemplating possibilities once dismissed. The pattern itself may be the message, and the message is unequivocal: pay heed. The matter of acceleration stands as one of the most unsettling facets of interstellar visitors. When Oumuamua was initially tracked, astronomers noted something peculiar. Its trajectory, while hyperbolic as anticipated, did not precisely conform to the curve predicted by gravity alone. There was a residual acceleration, minute yet persistent, subtly deviating its course. The conventional explanation would involve jets of sublimating ice expelling outwards, gently propelling the surface like microscopic thrusters. However, no coma, no tail, no visible emissions were detected. The mystery persisted unresolved. Was the acceleration natural yet obscured? Or was it something else entirely? That question set the precedent for all subsequent interstellar entities. Borisov did not introduce complications in precisely the same manner. Its acceleration aligned with cometary behavior, characterized by a bright coma and predictable jets. It provided reassurance to the scientific community that outgassing can indeed account for minor deviations. Yet, the shadow of Oumuamua lingered, a potent reminder that anomalies in acceleration might not always yield to straightforward explanations. When Atlas appeared, the community observed with keen attention. Its velocity was greater, its chemistry stranger, and its coma unusually dominated by carbon dioxide. The potential for it also to exhibit unexplained acceleration haunted the early tracking efforts. Acceleration is significant because it distinguishes between passivity and activity. A purely gravitational trajectory is passive, a predictable outcome of mass and motion. Anomalous acceleration implies activity, something internal or external influencing the course. In natural terms, this typically signifies sublimation, but in speculative terms, it might indicate propulsion. That singular distinction is what keeps astronomers awake at night. If an object originating from beyond the solar system demonstrates sustained directed acceleration inconsistent with natural processes, the implications are profound. It would suggest that we are not merely observing geology, but engineering. For Oumuamua, one controversial hypothesis posited it might be a solar sail, a delicate membrane propelled by radiation pressure. The slight, steady acceleration aligned with what such a structure would experience when subjected to photon pressure. The absence of a coma, coupled with its elongated form, rendered the concept plausible enough for serious consideration. Others countered that exotic forms of outgassing, undetectable within the available data, could explain it. The debate remains inconclusive. However, the crucial point is that acceleration anomalies cannot be lightly dismissed. They delineate the boundary between the natural and the potentially artificial. When Atlas was first analyzed, its substantial velocity drew considerable attention. Traveling at over 61 kilometers per second relative to the Sun, it possessed nearly double the excess speed of its predecessors. This raised a disquieting possibility. Was it merely a consequence of violent ejection from its home system? Or had it been deliberately accelerated across galactic distances? Natural processes can generate such velocities. Close encounters with massive planets, gravitational slingshots around multiple stars, or chaotic interactions within dense stellar clusters can propel objects outward with extraordinary speed. However, the escalation across 3 arrivals, 26 kilometers per second, 32, then 61, forms a pattern difficult to overlook. Acceleration once again loomed as a central inquiry. Tracking an interstellar object necessitates precise astrometry. This involves measuring its position against background stars night after night. Any deviation from the gravitational path becomes evident in the residuals, the minor discrepancies between prediction and observation. For Atlas, astronomers meticulously scrutinize these residuals with particular care. If they revealed unexplained thrust, the world would undoubtedly take notice. Initial reports indicated nothing dramatic, only the expected perturbations from outgassing and radiation pressure. Yet, the coma's composition complicated interpretation. Carbon dioxide jets behave differently from water ice, releasing energy at varying distances from the Sun. The resulting accelerations are more challenging to model, leaving room for ambiguity. And ambiguity is the fertile ground for conjecture. The question extends beyond the object itself to the broader context of interstellar travel. Acceleration represents the primary obstacle. Moving between stars within less than geological timescales requires velocities far exceeding those typically provided by gravity alone. For a civilization to dispatch probes, they must surmount the acceleration challenge, either through sails, fusion, antimatter, or means we cannot yet conceive. When we observe an object like Atlas arriving with extreme velocity, we must question whether it signifies a natural occurrence, such as ejection and violence, or an artificial one, namely propulsion. The distinction is tenuous. and our instruments are limited. However, the question refuses to dissipate. There is also the issue of deceleration. If an object were genuinely a probe, it might need to reduce speed upon arrival to observe, communicate, or linger. To date, none of the three interstellar visitors have displayed any evidence of deceleration. Their paths remain hyperbolic, ensuring their eventual departure from the solar system. Yet, this too can be interpreted in multiple ways. Perhaps they are natural entities, propelled by chance and indifferent to us. Or perhaps they are designed to pass through swiftly, gathering data silently without halting. A flyby reconnaissance mission necessitates no deceleration, only speed and stealth. In this light, hyperbolic trajectories do not preclude design. They may, in fact, support it. Acceleration also intersects with detectability. If propulsion is subtle, it could be obscured by natural outgassing. A probe, masquerading as a comet, might intentionally align its thrust with anticipated sublimation patterns, ensuring that any acceleration appears natural. The prevalence of carbon dioxide in Atlas further complicates matters, as models for such activity are less developed than for water-driven comets. If an intelligence sought to conceal artificial acceleration, this would represent an ideal camouflage. What appears as peculiar chemistry could, in reality, be controlled manipulation. Skeptics maintain that extraordinary claims demand extraordinary evidence, and no interstellar object has yet provided evidence sufficiently compelling to cross that threshold. Acceleration anomalies remain explainable by natural means, however strained those explanations may be. Yet, history reminds us that anomalies often precede discovery. The unexplained acceleration of Uranus led to the discovery of Neptune. The anomalous precession of Mercury's orbit provided the foundation for general relativity. What we dismiss as noise may later reveal new physics or new realities. If interstellar visitors consistently exhibit unexplained accelerations, we may be on the cusp of another paradigm shift. The debate surrounding Atlas's velocity also connects to its origin. If it truly hails from the galaxy's thick disk, an older stellar population characterized by chaotic dynamics, then its high speed might simply reflect that heritage. Objects from such regions exhibit different movement patterns, less aligned with galactic rotation and possessing more random orbits. However, this explanation merely postpones the mystery. Why should the initial 3 detected visitors all originate from unusual environments? Why should their velocities escalate in a pattern that mimics deliberate testing? Acceleration, irrespective of whether it is natural or artificial, becomes the lens through which the broader enigma is refracted. Another dimension of the inquiry involves energy. Accelerating even a minor comet to interstellar velocities demands immense energy reserves. Natural processes achieve this through planetary interactions over millions of years. Artificial processes would necessitate technology far beyond our current comprehension. Nevertheless, if such technology exists, the universe may already be populated with accelerated probes. Silent travelers launched eons ago, still coasting through space. Atlas might be one such entity, indistinguishable from natural debris save for its timing and chemical composition. The distinction between random celestial debris and a guided messenger lies not in its trajectory but in the intention behind it. Intention is the most challenging aspect to detect. Acceleration also holds significance for humanity's own future. As we contemplate the prospect of dispatching probes to other star systems, we confront the identical barrier. Breakthrough Starshot, a proposed endeavor to propel nanoscale sails towards Alpha Centauri, relies on acceleration via powerful lasers. The objective is to achieve 20% of the speed of light, sufficient to traverse 4 light-years within a human lifetime. However, deceleration remains an unresolved challenge. We envision acceleration because it represents the initial step, the indispensable impetus into the interstellar void. Observing Atlas compels us to reflect. Are we witnessing the same process executed by an entity far older and more advanced? Are these objects not merely wanderers, but tangible demonstrations of the very technologies we aspire to develop? For the present, the prevailing consensus remains cautious. No definitive unexplained acceleration has been confirmed for Atlas. The data align with natural processes, albeit unusual ones. However, consensus is not synonymous with certainty. It reflects what can be substantiated with current evidence. The possibility of concealed propulsion persists, not due to conclusive proof, but because it cannot yet be definitively ruled out. The persistent query regarding propulsion methods will continue to vex any extraterrestrial travelers we identify, dictating how we decipher their intentions. Ultimately, the distinction between a celestial timetable and a cosmic summons might hinge on this very inquiry. Should an entity exhibit acceleration beyond our current comprehension, the notion of pure chance weakens. If its trajectory remains solely governed by gravitational forces, then mere happenstance remains a credible explanation. Each subsequent observation serves to prune the realm of possibilities, yet none have conclusively eliminated them all. We find ourselves adrift in a sea of uncertainty, caught between the solace of naturalistic reasoning and the disquiet of artificial origins. The question of propulsion acts as the fault line separating these two perspectives. And until it is definitively answered, every arrival from the void will carry an undeniable aura of scrutiny. Thus our vigil persists. We meticulously examine light fluctuations, quantify discrepancies, and contrast various theoretical frameworks. We deliberate whether effusions of carbon dioxide can account for the observed phenomena, whether the pressure exerted by radiation suffices, or if undisclosed mechanisms are at play. The enigma endures, hovering at the precipice of certainty, unresolved, unrefuted, and patiently awaiting resolution, much like the objects themselves, traversing the boundless expanse of space with speed, silence, and elusiveness. Long before the array of telescopes situated in Chile pinpointed the faint luminous trace that eventually became designated as 3 Atlas, whispers were already circulating within the scientific community concerning the subtle indications we might anticipate preceding such an interstellar arrival. These were not signals in the conventional sense of coded messages or deliberate transmissions, but rather subtle indicators, patterns embedded within ambient noise, transient anomalies in radio data, or peculiar orbital alignments that suggested an approach. The cosmos possesses a remarkable ability to communicate in hushed tones before issuing a resounding declaration. And a significant part of the fascination surrounding Atlas stems from the suspicion that these whispers might have been present all along, had we only possessed the discernment to attend to them with sufficient care. Radio astronomers have a history of documenting ephemeral signals, sudden energetic bursts lasting mere milliseconds. The majority of these are now classified as fast radio bursts. While many originate from galaxies billions of light years distant, a subset defies such straightforward localization, appearing with an almost deliberate proximity. Some of these detections occurred months prior to the official announcement of Atlas, prompting a small cohort of theoreticians to explore potential correlations. Could there have been an antecedent signal, a kind of marker indicating the impending arrival of an interstellar entity? The official response is a categorical absence of confirmation. Nevertheless, silence alone has never been sufficient to quell profound curiosity. If we conceptualize interstellar entities as potential emissaries, then the notion of precursor signals gains considerable traction. A probe might subtly announce its presence before entering our solar system, not through an overt transmission, but through ambient fluctuations that only the exceptionally attentive would register. Even a naturally occurring object could inadvertently generate signals. As it navigates through interstellar plasma, its interaction with magnetic fields might produce faint radio emissions. Should such emissions have occurred, they would be effectively submerged within the vast ocean of cosmic static, undetectable until someone specifically sought them out. And with the discovery of Atlas, a select few researchers commenced a re-examination of historical data, actively searching for precisely these phenomena. This suspicion was further amplified by the temporal aspect. During the spring of 2025, numerous observatories reported anomalous transient signals within low frequency bands. Each instance was swiftly attributed to interference, the unavoidable byproduct of terrestrial electronic systems encroaching upon sensitive instruments. However, following the detection of Atlas months later, those transient signals were revisited with a fresh perspective. Could they have represented early indicators? No definitive proof has been established. Yet, the possibility lingers, undeniably compelling. If celestial bodies can indeed be heralded by preceding signals, then the demarcation between passive discovery and active engagement becomes blurred. We might not merely be discovering them, they could be announcing themselves. Naturally, the position of a skeptic remains unequivocally straightforward. The cosmos is inherently replete with noise, extraneous signals, transient natural phenomena, and statistical anomalies. These factors account for the vast majority of observed irregularities. Attributing significance in retrospect is a common human cognitive bias. We only perceive the significance of a transient event once a subsequent occurrence imbues it with meaning. Had Atlas not materialized, these preceding signals would likely have remained unremembered. Correlation does not inherently imply causation. Nevertheless, the disquieting aspect is the frequent occurrence of the cosmos, presenting unexpected revelations subsequent to the observation of anomalies. Pulses were initially dismissed as interference. Cosmic microwave background radiation was erroneously attributed to pigeon droppings on an antenna. Signals that initially appeared trivial subsequently revolutionized scientific understanding. The risk of overlooking potential precursors is as substantial as the risk of overinterpreting them. Signals preceding discovery are not necessarily confined to the electromagnetic spectrum. They can also manifest gravitationally, albeit too subtly for our current instrumentation, yet theoretically detectable. An object of Atlas's considerable mass, traversing interstellar velocities, exerts a gravitational influence on the solar system long before it becomes optically visible. Minute perturbations in the orbits of known asteroids, faint shifts in the timing of signals from distant spacecraft. Even minor deviations in planetary positions could function as early warning indicators. Our present technological capabilities are not yet sufficiently refined to consistently discern such subtle whispers. However, in the future, with interconnected networks of highly precise detectors, we may be able to identify interstellar objects considerably in advance of their passage through the inner solar system. The concept of signals preceding discovery is not merely plausible, it is likely inevitable. We simply are not yet equipped to perceive them. This introduces a disconcerting question. If we possessed the capacity to detect such precursors, should we? Awareness fundamentally alters the nature of the relationship. The reception of a signal prior to the object's arrival allows for preparation, conjecture, and even apprehension. The unknown has a profound capacity to shape societal structures, and the knowledge of an impending arrival from beyond our known sphere would undoubtedly be met with considerable gravity. Perhaps it is more prudent for such signals to remain undetected until the object itself manifests, silent and irrefutable, thereby affording no opportunity for fear to take root. The precise timing of a discovery might, in itself, constitute an intrinsic element of the message, ensuring that we become apprised of the visitor only when it is too late for an excessive reaction. However, a contingent of individuals posits that the signals have, in fact, already been perceived, but deliberately withheld from public disclosure. Intelligence agencies, private astronomical institutions, and classified surveillance networks all scrutinize the heavens with instruments far exceeding the capabilities accessible to the general public. If Atlas was indeed preceded by anomalous readings, it is conceivable that certain entities possessed prior knowledge before July 1st, 2025. The official announcement of its discovery might have represented its public unveiling rather than its initial detection. Such conjectures flourish in environments characterized by a lack of transparency. And once articulated, the notion becomes exceedingly difficult to dismiss. It is possible that signals preceding discovery are not intended for widespread dissemination, but rather for a select audience already attuned to such phenomena, individuals who have proactively prepared themselves for circumstances that the rest of humanity is only beginning to confront. Another dimension of this ongoing discourse involves the realms of mythology and folklore. For millennia, diverse cultures have interpreted inexplicable celestial lights, unexplained auditory phenomena, and unusual astronomical occurrences as premonitions of comets yet to appear. Narratives of celestial trumpets, sudden stars heralding impending pestilence, and unusual auroral displays were all woven into cautionary tales. In retrospect, these were likely natural events that coincidentally coincided with cometary appearances. However, the resonance with contemporary suspicions is remarkably striking. Ancient peoples held a belief in pre-discovery signals. Modern scientists, armed with sophisticated instruments and vast data sets, find themselves contemplating the same fundamental question, albeit through a different linguistic framework. The underlying pattern persists, repeating itself across millennia. We observe that which is unusual and ponder whether it portends future events. Furthermore, there exists the possibility that signals are indeed present, but are intentionally designed to be inconspicuous. Should a probe aim to communicate on a selective basis, it might employ narrow directional beams, frequencies detectable only by specific instruments, or encoded signals that, without appropriate processing, closely resemble random noise. It is conceivable that we have been receiving such signals for decades, oblivious to their meaning due to our inherent assumption of randomness. The arrival of Atlas may serve as a catalyst, prompting us to re-examine historical datasets with novel perspectives, actively seeking patterns that previously eluded our notice. The object itself could function as a key, guiding us on where to direct our attention and how to interpret incoming information. In this context, the signal and the discovery can be viewed as two complementary halves of a singular message. Even explanations rooted in natural phenomena can possess an uncanny quality. A comet emitting an unusually high concentration of carbon dioxide might exhibit a distinct infrared signature long before it becomes visible in optical wavelengths. Telescopes surveying the sky in these specific spectral bands might record anomalies without immediately identifying their source. When the object subsequently becomes optically observable, these recorded anomalies are retrospectively reclassified as preliminary signals. We do not always possess the immediate understanding of what we are observing until contextual information becomes available. It is plausible that Atlas was communicating in subtle ways long before we recognized its capacity for overt articulation. The most radical hypothesis proposes that these signals are not precursors at all, but rather invitations. The very act of discovery might have been meticulously orchestrated, our instruments guided, and our temporal alignment manipulated to ensure that we would indeed find the object at that specific juncture. From this viewpoint, the signal does not reside in the celestial expanse, but within humanity itself, embedded in our innate curiosity, in the cascade of decisions that led to the construction of telescopes, the design of observational surveys, and the global dissemination of data. The summons preceded the object, but the signal was intrinsically human, amplified by whatever unseen force facilitated this remarkable coincidence. Consequently, discovery shifts from being about what we have found to being about what we were intended to discover. For the scientific community, the immediate imperative is to rigorously investigate these hypotheses without succumbing to unfounded conjecture. Archival data must be exhaustively analyzed for anomalies, radio transients meticulously revisited, and infrared surveys subjected to renewed scrutiny. If correlations with interstellar arrivals can be definitively established, they must be demonstrated with unwavering scientific rigor. Conversely, should no such correlations emerge, the prevailing suspicion will gradually recede into the ambient background noise of scientific inquiry. However, even in its dissipation, this suspicion will undeniably shape our future approach to subsequent interstellar arrivals. Each new interstellar object will be preceded by a dedicated effort to scour past data, a systematic ritual of seeking antecedent signals before the primary discovery. This pattern is likely to repeat, not out of a fervent expectation of confirmation, but rather because the possibility itself cannot be casually disregarded. What is undeniably clear is that the process of discovery does not commence with the public announcement of detection. It originates much earlier, in those faint signals that may or may not possess inherent meaning, in those transient blips that may or may not exhibit a discernible alignment. The narrative of Atlas did not truly begin on July 1st. It commenced with a series of whispers dispersed across many months, potentially even years, awaiting the arrival of context to weave them into a coherent whole. The presence of signals preceding discovery serves as a potent reminder that the cosmos rarely makes its grand entrances without any preamble. It is engaged in a perpetual state of communication. The fundamental challenge lies not in the existence of these signals, but in our capacity, or lack thereof, to discern them. Upon the appearance of 3 Atlas within the data stream, the prevailing narrative was framed through the lens of pure scientific inquiry. It was characterized as a hypervelocity visitor from beyond our solar system, its trajectory meticulously confirmed, its chemical composition analyzed, and its orbital parameters recorded with exceptional precision. Yet, beyond the confines of astronomical observatories, an alternative narrative was concurrently unfolding. This narrative was deeply rooted in a far more ancient method of celestial interpretation. For millennia, comets have been regarded not merely as itinerant icy bodies, but as potent symbols, harbingers of change, omens, or promises of future events. Ancient civilizations meticulously inscribed their presence into prophetic texts, intertwining astronomical observations with notions of destiny. Now, with telescopes possessing unprecedented power, trained upon an interstellar visitor, the confluence of ancient prophecy and contemporary discovery becomes virtually inescapable. The same celestial expanse that once inspired both apprehension and profound reverence is now revealing mysteries that science itself grapples to definitively explain. In ancient Mesopotamia, inscribed clay tablets chronicle cometary appearances alongside pronouncements of impending famine or warfare. The Babylonians meticulously charted celestial occurrences, firmly believing they reflected the divine will of their gods. A sudden luminous streak traversing the heavens was never considered devoid of meaning. It was unequivocally a message. Centuries later, Roman chroniclers documented comets as portents of significant political upheaval. The demise of Julius Caesar, they asserted, was presaged by a brilliant comet, interpreted as the ascension of his spirit. In China, ruling dynasties perceived comets as indicators of lost or renewed imperial authority. The diligent astronomers of the Han court meticulously recorded each comet not solely as a natural phenomenon, but as a signal with profound earthly repercussions. This pattern of interpretation was globally consistent across diverse cultures. Comets were regarded as prophecy and celestial motion. Fast forwarding to the present, the vernacular has evolved, yet the underlying human inclination remains constant. When astronomers disclose the peculiar chemical composition of Atlas, notably its disproportionate abundance of carbon dioxide, certain segments of the public instinctively turned to older interpretive frameworks. Was this a portent, a signifier of transformation? Was the universe communicating in a manner that our ancestral predecessors would have recognized, even though it is now cloaked in scientific terminology? The connection between prophecy and the modern telescope lies not in the methodological approach, but in the perceptual framework. Both systems regard the celestial sphere as imbued with meaning. Both operate under the assumption that when the heavens present something extraordinary, it carries a significance that transcends mere physical processes. The fundamental difference resides in the fact that contemporary telescopes furnish details unimaginable to ancient skywatchers. The James Webb Space Telescope does not simply register luminosity, it meticulously dissects light into its constituent spectra, thereby revealing intricate chemical fingerprints. Ground-based arrays achieve trajectory measurements with extraordinary precision, accurate to fractions of an arcsecond. Radar technology enables probing of the cometary coma, facilitating the detection of particle sizes and velocities. The resultant data is immeasurably richer and the analytical processes more refined. However, the emotional core, the pervasive sense of awe and underlying unease, is not fundamentally dissimilar to what ancient astronomers experienced. They too gazed upwards, observed something unexpected, and posed not only the question of its identity, but also its significance in relation to its timing. That question of why remains as open in our era as it was in theirs. One could argue that prophecy and modern astronomy share no common ground, that scientific advancement has superseded superstitious beliefs. However, historical evidence suggests a continuum of understanding. Numerous discoveries were initially perceived as omens before they were recognized as natural phenomena. Solar eclipses, once dreaded as harbingers of doom, are now predictable centuries in advance. Meteor showers, once viewed as celestial portents, are now understood as the intersection of Earth's orbit with debris streams. Comets themselves, once interpreted as divine warnings, are now recognized as the icy remnants of planetary formation processes. Yet the transition from prophecy to telescopic observation is not a stark rupture, but rather a profound transformation. The language evolves, the investigative methods sharpen, but the fundamental human impulse to discern meaning in the celestial expanse persists. Atlas presents a challenge to this evolutionary trajectory because it resists facile categorization. Its chemical makeup defies established classifications. Its velocity strains the boundaries of naturalistic explanations. Its precise timing provokes suspicion. In ancient terminology, it would have been readily interpreted as a potent omen, a celestial pronouncement of immense magnitude. In contemporary scientific terms, it is designated as an anomaly, the subject of numerous scholarly papers and scientific conferences. Nevertheless, the palpable resonance between these disparate interpretations is undeniable. Both frameworks acknowledge that this visitor is not ordinary, that it stands apart from the familiar spectrum of known comets. Ancient prophecy and modern telescopic observation converge in their recognition of an extraordinary phenomenon. Furthermore, there is the consideration of cultural memory. Myths often encode significant astronomical events within symbolic narratives. Legends of global floods might recall ancient impact events. Tales of fiery celestial chariots could represent meteoric displays. Divine messengers might in fact be symbolic representations of comets. If interstellar visitors have indeed traversed our solar system in the past, it is plausible that their presence is embedded within ancient stories, remembered not as icy wanderers, but as significant signs. In the absence of sophisticated telescopes, ancient peoples lacked the means to measure hyperbolic trajectories, but they were capable of meticulously recording the sudden appearance of a comet, its peculiar luminosity, and its eventual departure, never to be seen again. Such historical records may exist, scattered throughout mythology, awaiting reinterpretation by modern scientific scrutiny. The boundary separating prophecy from empirical data is far more tenuous than it might initially appear. Modern telescopes, despite their remarkable power, still grapple with achieving absolute certainty. Spectroscopic readings can be inherently ambiguous, theoretical models are often incomplete, and observational data can be prone to noise. Ancient prophecy, conversely, filled these informational gaps with narrative, ingeniously weaving meaning into spaces where precise measurement faltered. In the present day, we endeavor to fill these gaps with speculative hypotheses, which can sometimes be equally dramatic in their scope. Was a solar sail? Was Atlas deliberately summoned? These inquiries are not fundamentally dissimilar to ancient pronouncements of dynastic change or impending doom. They represent narratives constructed in response to uncertainty. The telescope does not obliterate prophecy. Rather, it modernizes it. The key distinction is that our contemporary prophecies are formulated as hypotheses, subject to empirical testing against available data, yet still retaining the compelling force of human imagination. The linkage between prophecy and telescopic observation also manifests in the aspect of timing. Ancient cultures widely believed that comets appeared during periods of significant societal transition, marking pivotal junctures in human history. Modern scientists have similarly observed this recurring coincidence. Interstellar visitors emerging precisely at the historical moment when humanity has acquired the technological capability to detect them. The interpretive frameworks, however, diverge. Ancient peoples attributed these occurrences to divine intervention or cosmic will. Scientists tend to attribute them to improbable coincidence, yet the inherent resonance between these perspectives is unmistakable. Both frameworks implicitly assert that the celestial realm is not a domain of pure randomness. Both ascribe significant meaning to the timing of events. The ancient lexicon employed the term omen. The modern vernacular utilizes anomaly. However, the underlying pattern remains shared. In a fundamental sense, prophecy and the practice of telescopic astronomy represent two distinct facets of humanity's response to the unknown. One seeks meaning through narrative construction, while the other endeavors to find it through rigorous measurement. Yet both are stimulated by the same catalyst, an unexpected entity originating from the celestial expanse. When Atlas made its dramatic appearance, both of these human responses were simultaneously activated. The astronomer meticulously logged its orbital parameters. The public, on the other hand, began to speculate about its potential significance as a sign. Both factions, in their own way, pose the same fundamental question: why now? This convergence of ancient interpretive methods and modern scientific inquiry raises a possibility that few are willing to acknowledge. What if ancient prophecy was not entirely devoid of underlying truth? What if comets and interstellar visitors do, in some fundamental way, carry meaning? Not divine, perhaps, but communicative in nature? If civilizations predating our own have employed such celestial objects as messengers, then the ancients may have been correct in their perception of them as signs, even if they misinterpreted the ultimate source. The deities they envisioned might have served as metaphorical representations of something far more profound: intelligent entities originating beyond Earth, transmitting messages through the only medium guaranteed to transcend the boundaries of time and space, celestial bodies composed of rock and ice cast across the vastness of the galaxy. From this perspective, prophecy can be viewed as proto-astronomy. Telescopes, in essence, merely refine what mythical traditions had already intuited. Skeptics invariably dismiss this line of reasoning as an overly romanticized interpretation of ancient myths. To them, prophecy represents a form of superstition entirely divorced from scientific inquiry. However, historical precedent serves as a cautionary reminder against intellectual arrogance. Numerous fundamental truths were once enshrouded in mythological narratives before science progressively unveiled them. Thunder was once attributed to Zeus's divine wrath, only to be subsequently understood as the phenomenon of lightning. The rainbow was once conceived as Iris's celestial pathway, subsequently revealed to be a consequence of light refraction. While ancient myths may have been inaccurate in their specific details, they often captured an essential intuitive truth. The universe is not mundane, but rather is replete with forces that elude our complete comprehension. The same may hold true for comets, once considered omens. They may have been theologically inaccurate, but perhaps accurate in their essence, that the arrival of unusual celestial visitors carries significant import. Modern telescopes provide us with the essential tools to rigorously test this very possibility. If future interstellar objects appear in discernible patterns, exhibiting escalating anomalies, then the ancient prophecies concerning the significance of cometary series may find themselves strangely vindicated. The ancients posited that comets appeared in sequences of profound importance, and scientific observation may ultimately confirm the statistical improbability of such sequential occurrences. Should future arrivals exhibit evidence of chemical encoding, possess discernible geometric structures, or manifest with suspicious temporal regularity, then the ancient assertion that comets serve as messages will gain a profound and compelling resonance. While we may no longer refer to them as omens, the ultimate effect will be remarkably similar. The cosmos will be speaking, and we will be actively listening, employing sophisticated instruments rather than ancient myths as our medium of understanding. Atlas occupies a pivotal juncture where these two distinct traditions intersect. For the general populace, its arrival evokes the feeling of an omen, strange and inherently unsettling. For the scientific community, it represents a wealth of data, puzzling and, as yet, incomplete. However, for both groups, it undeniably carries significant meaning. The telescope does not erase the legacy of prophecy. Instead, it transforms it into rigorous analysis, reframing ancient intuitions as the subject of contemporary research. Yet the fundamental human response, the innate recognition that the celestial expanse is conveying something to us, remains irrevocably unchanged. Ancient prophecy and modern telescopic observation are not adversaries but rather echoes of a shared human experience. Each interprets the visitor as a reflection of humanity's enduring questions, whether those questions were articulated on clay tablets or within digital data streams. Consequently, the narrative is not one of prophecy's obsolescence, but rather of its evolution. Where once a comet observed over Rome was interpreted as an omen foretelling Caesar's fate, now an interstellar visitor detected over Chile signifies humanity's profound inquiries into the possibility of intelligence beyond Earth. The language has undeniably shifted, but the underlying structural framework remains precisely the same. The cosmos delivers something anomalous, and humanity collectively asks, why now? What is its intrinsic meaning? And how should we, as a species, endeavor to respond? These are questions that transcend temporal boundaries, as ancient as the very first prophecy, and as current as the latest advancement in telescopic technology. The arrival of Atlas signifies more than a scientific breakthrough. It represents a cultural crossroads where ancient intuition meets contemporary precision. The ancient prophecies are no longer etched in stone, but are now published in scientific journals. And the telescope, once a symbol of divine will, has become a testament to human curiosity. Despite these shifts, both pursuits gaze upon the same celestial expanse, grappling with the same profound enigma. When the cosmos delivers the unexpected, is it mere chance or a deliberate communication? When astronomers first chart the trajectory of a celestial newcomer, the mathematical figures are intended to speak solely of gravitational forces. The orbital parameters are meant to reveal its origin, its future path, and the duration of its visibility. These are presumed to be the most objective data points, devoid of interpretation, simply the silent language of cosmic motion. However, with the advent of the third visitor, dubbed Atlas, some began to contemplate whether these numerical values themselves might harbor a deeper significance. If one were to transmit a message across the vastness of interstellar space, what more fitting medium could there be than the mechanics of celestial orbits? Trajectories are observable by any civilization possessing telescopes and are immune to linguistic barriers, cultural disparities, and variations in biological perception. A celestial path is universally comprehensible. Thus, the question emerges, could the orbit itself constitute a message? The inclination of Atlas's orbit was particularly striking. It deviated from alignment with the galactic plane and was inconsistent with typical ejection scenarios, traversing the solar system at a sharp angle that ensured its visibility from Earth's vantage point. Its perihelion distance brought it sufficiently close to the Sun to trigger the formation of a coma, yet not so near as to cause its disintegration. The timing of its perihelion passage was calculated to maximize observation opportunities for both ground-based telescopes and sophisticated instruments like the James Webb Space Telescope. At every conceivable juncture, the orbit appeared meticulously designed to attract maximum attention. Was this mere happenstance or a carefully orchestrated performance? When orbital mechanics is perceived as a form of communication, subtlety becomes paramount. A singular flyby might be readily dismissed as random. However, a series of flybys, each with orbits precisely calibrated for specific observational windows, could transform into an unmistakable signal. The first three interstellar visitors already hint at a deliberate progression. One, characterized by its elongated shape and erratic tumbling, suggested artificial origins. Another, a textbook comet, served to establish a baseline of familiarity. The third, Atlas, exhibited anomalous chemical composition and arrived at a moment timed for peak scientific scrutiny. Now, consider their orbital paths. Each entered the solar system from a distinct direction, ensuring comprehensive coverage by sky surveys. Each departed in a manner that precluded further tracking, thus ensuring fleeting observation. If this pattern continues, the very principles of orbital mechanics could be revealing a hidden narrative. In communication theory, a message requires not only a signal, but also structure. Here, the signal is the object's path through the solar system, and the structure is the sequence of these paths. If the orbits of interstellar visitors exhibit patterns that are statistically improbable, they may function as encoded messages, not composed of words, but of rhythms, not alphabets, but alignments, a series of entries meticulously arranged to create geometric relationships visible only to those who meticulously plot them. Astronomers already engage in such analysis. They map orbits, compare inclinations, and calculate velocities. What if these very calculations are the intended medium of the message? Consider the potential for triangulation. If 3 or more interstellar visitors are plotted, their inbound vectors might converge on a specific point in space, possibly indicating their origin or deliberately serving as a directional clue. Already, some theorists have observed that Oumuamua, Borisov, and Atlas do not appear scattered randomly across the sky. Their trajectories intersect in ways that form geometric patterns, although the current sample size is too limited to draw definitive conclusions. However, if 10 or 20 more such objects are detected, and these patterns persist, suspicion will inevitably mount. After all, orbital mechanics is the singular language guaranteed to be understood by any civilization advanced enough to observe the cosmos. Even without multiple objects, a solitary orbit can convey meaning. The perihelion distance can be precisely calibrated, the inclination meticulously chosen, and the approach velocity adjusted. If Atlas's high velocity and steep inclination were deliberately selected, they may communicate something about the sender's capabilities, speed as a demonstration of power, inclination as a marker of intentionality, and perihelion distance as an indicator of precision. Every orbital parameter could possess symbolic value. To us, they are mere numbers on a chart. To them, they might constitute an alphabet. The orbit transforms into both a passage and a declaration. Skeptics contend that this interpretation is an act of anthropomorphism. Orbital elements, they argue, are the product of gravity, not linguistic expression. The interstellar void is replete with ejected debris and random processes, given sufficient time, can produce any conceivable combination. To ascribe meaning is to project human intention onto phenomena where none exists. Yet history provides a cautionary reminder that randomness rarely arranges itself with such meticulous order. If objects consistently arrive on trajectories that ensure optimal visibility, the suspicion cannot be reasonably dismissed. The boundary between chance and signal, though perhaps faint, is not imaginary. Furthermore, there is the matter of redundancy. A radio transmission can be lost amidst cosmic noise, but an orbit, once plotted, is immutable and undeniable. A message encoded in a celestial trajectory persists across cultures, across centuries, and across technological levels. Even a civilization equipped with only rudimentary telescopes can discern the object's path. This inherent resilience makes orbital mechanics an ideal communication medium. If a civilization wished to announce its presence unequivocally, dispatching objects on deliberate orbits would represent the most straightforward and universal method. The geometric configuration of Atlas's path only amplifies the intrigue. It entered our solar system from a region of the sky near LRA, a constellation already significant within SETI, search for extraterrestrial intelligence circles due to past radio anomalies. Its exit vector, post-perihelion, points towards star-sparse regions, seemingly designed to avoid immediate association with any particular origin. To some, this is mere coincidence. To others, it resembles misdirection, a form of orbital choreography intended to obscure its origin while still ensuring visibility. If orbital mechanics serves as the message, then a portion of that message might be, "We are present, but you cannot yet locate us." An alternative interpretation suggests that the message lies not within the orbit itself, but in its interaction with human endeavors. Atlas's trajectory facilitated observation by every major observatory, spanning both the northern and southern hemispheres. This ensured global participation, transforming it into a unifying event for a planet often characterized by division. Perhaps the orbit was chosen not solely for its observational potential, but for its inclusivity, intended to compel humanity to act as a unified entity, pooling resources and data, and bridging cultural divides. If this is the case, then orbital mechanics transcends its role as a mere message to become a method, shaping human behavior through geometrical principles. This interpretation unexpectedly resonates with ancient prophecies. For early civilizations, the passage of a comet across the night sky was imbued with meaning, pointing towards celestial regions within the zodiac, aligning with seasonal cycles, and marking significant historical moments. Today, astronomers strive to strip away such symbolism, reducing the celestial path to mere numbers. Yet, the intrinsic human impulse to perceive trajectory as meaningful persists. Perhaps both perspectives hold validity. It is conceivable that orbital mechanics can function simultaneously as a fundamental physical law and a symbolic medium. In this sense, Atlas serves as a bridge between the ancient and the modern. The overarching question remains, can such messages be definitively proven? Asserting that orbits carry intention necessitates statistical evidence. A sufficiently large sample of interstellar visitors must be analyzed to determine if their paths deviate significantly from random expectations. If these objects cluster around specific inclinations, align with crucial observational windows, or form discernible geometric sequences, then the hypothesis gains substantial support. Until then, suspicion remains speculative. However, speculation is not entirely without foundation. Even the initial 3 arrivals have sparked considerable curiosity. The very fact that we are contemplating this question suggests that orbital mechanics, whether intended as a message or not, has already accomplished a significant purpose it has compelled us to ponder. From a practical standpoint, orbital mechanics also offers humanity a potential method of response. Should we ever wish to transmit a message devoid of language, we could deploy probes on carefully designed orbits intended to be conspicuous. A series of hyperbolic trajectories, timed centuries apart, and all converging on the same region of space, would be unmistakably clear to future astronomers in other systems. It is possible that this is precisely what we are currently witnessing, the echoes of another civilization's long-term initiative, their orbital messages traversing our solar system sequentially. The timescales involved are immense, and the patience required is unimaginable, but the underlying logic is sound. Orbits endure. Messages conveyed through motion outlast any written alphabet. Atlas, therefore, is not merely an object, but a harbinger of possibility. Its orbit may be random, a consequence of ejection eons ago, or it may be deliberate, chosen to ensure observation. At this juncture in our history, a definitive answer remains elusive. However, the very existence of this suspicion is significant. It alters our perception of every line on every orbital chart, transforming them from mere paths of rock and ice into potential sentences within a language far older and more expansive than our own. Orbital mechanics as a message, geometry as a script, the celestial sphere as a page. When astronomers calculate the trajectory of an interstellar object, the initial impression is one of complete indifference. These are equations of gravity and velocity, vectors plotted against the backdrop of stars, nothing more than the universe unfolding through its relentless mathematical laws. Yet with Atlas, as with its predecessors, a persistent suspicion lingers that these equations might not be as neutral as they appear. If an orbit can function as a message, then mathematics itself can embody intent. And it is intent that differentiates random occurrence from genuine communication. The mathematical description begins with 6 fundamental orbital elements: the semi-major axis, eccentricity, inclination, longitude of the ascending node, argument of perihelion, and mean anomaly. These parameters collectively define an object's path around the Sun. For interstellar visitors, the semi-major axis is characteristically negative, indicating a hyperbolic trajectory, and the eccentricity exceeds 1. The inclination defines the tilt of the orbit relative to a reference plane, while the remaining values refine the specific path. To astronomers, these are merely coordinates. However, to a civilization aiming to signal across the cosmos, they could represent a sophisticated code. Numbers serve as the most universal language. Any species capable of charting orbits will comprehend an eccentricity greater than 1. Any species adept at plotting inclination will understand geometrical principles. In this context, intent could be intrinsically embedded within the orbital parameters themselves. The critical question then becomes, are these parameters a product of natural processes, or were they deliberately chosen? A random ejection from a star system over billions of years results in a wide distribution of velocities and angles, with countless such bodies drifting through space. However, if we begin to observe values clustering within specific ranges or sequences that build upon one another, then mathematics transforms into something far more profound. Consider the progression observed thus far. Oumuamua exhibited an eccentricity just above 1 and a moderate inclination. Borisov presented a higher eccentricity and a different inclination. Atlas, in turn, displayed extreme eccentricity and a steep inclination. This sequence appears to represent an escalation, with each subsequent object pushing further outward, as if demonstrating a deliberate range of capabilities. This range itself could signify intent, showcasing what is possible and what is meant to be observed. Even the speed at infinity, the excess velocity with which an object enters and exits the solar system, can carry meaning. Oumuamua's speed was approximately 26 kilometers per second. Borisov's was near 32 kilometers per second, and Atlas's exceeded 61 kilometers per second. The mathematical relationships within these values invite comparison. They do not appear random from a human observational perspective. They exhibit order. A doubling of speed across 3 objects cannot be definitively proven as intentional, but it strongly evokes the concept of design. If the next interstellar visitor arrives at an even greater velocity, suspicion will undoubtedly deepen. Mathematics is fundamentally about patterns, and patterns inherently suggest intent. Skeptics argue that we are projecting significance onto limited data. With only 3 examples, any sequence can appear meaningful. However, human history demonstrates that mathematics has frequently unveiled intent hidden within apparent noise. The regularity of planetary motions, for instance, led to the discovery of the heliocentric model. The subtle precession of Mercury's orbit provided evidence for Einstein's theory of general relativity. In each of these instances, numerical data betrayed deeper underlying structures. If interstellar visitors exhibit mathematical sequences, then perhaps they too betray something beyond mere randomness. Numbers are not solely descriptive. They can function as signatures. Consider another aspect: ratios. When spectra are analyzed, scientists measure the ratios of various gases. For example, the ratio of water to carbon dioxide or carbon monoxide to methane. These are fundamentally numbers. Atlas presented ratios never before observed, with carbon dioxide dominating almost to the exclusion of other compounds. Such extreme numerical values could be accidental, or they could represent deliberate emphasis. In communication, emphasis is achieved through repetition, exaggeration, and making something stand out. In Atlas's case, the carbon dioxide ratio was so pronounced that it demanded attention. Numbers falling outside expected ranges function as signals, compelling recognition irrespective of whether intent was involved. Mathematics also facilitates universal communication. Languages fragment and diverge across cultures, but numbers remain constant. Pi is universally recognized as pi. An eccentricity greater than 1 signifies a hyperbolic trajectory everywhere. Ratios are inherently the same, regardless of cultural context. If a civilization sought to leave an unmistakable trace, mathematics would be the ideal medium. An interstellar object visible to anyone with telescopes provides the canvas, its orbital elements, its chemical ratios, its rotational period. Each is a number, and numbers transcend biological limitations. Intent could be encoded simply by selecting these numbers with deliberate care. The concept of mathematics as intent also intersects with probability. Astronomers calculate the likelihood of detecting interstellar objects based on estimated rates. Prior to 2017, this estimate was perhaps 1 detection per century. After the arrival of 3 such objects in less than a decade, the probability has dramatically shifted. If these are natural occurrences, then our previous models were fundamentally flawed. If they are intentional, then probability itself becomes a crucial clue. Numbers that deviate significantly from expectation point towards deliberate design. The mathematics of frequency is as telling as the mathematics of orbital mechanics. 3 arrivals in rapid succession might be coincidental, but a coincidence measured by its improbability is indistinguishable from a deliberate message. Furthermore, symmetry is a factor to consider. If future interstellar visitors arrive exhibiting mirrored inclinations, complementary eccentricities, or resonant timing, their mathematical signature will become undeniable. Patterns of symmetry are exceptionally rare in chaotic systems. They are hallmarks of design. Even now, theorists are actively searching for such symmetries, plotting inbound trajectories to uncover hidden relationships. The mathematics of intent may not be immediately apparent until a substantial amount of data has been collected. But once recognized, it will be impossible to ignore. One might question why an advanced civilization would choose mathematics as its communication medium. The answer lies in its inherent universality and reliability. Any biology capable of constructing telescopes must by necessity understand motion and number. Physics dictates this. Unlike language, which is often arbitrary and culturally specific, mathematics is embedded within the very fabric of reality. To signal intent through mathematics is to rely on the one fundamental aspect that all intelligences share, the laws of nature. Consequently, a comet's path can be interpreted as both a natural phenomenon and a potentially deliberate act. To us, it is an orbit. To them, it is grammar. Skeptics counter that mathematics cannot definitively prove intent. Numbers, they argue, merely describe. They do not explain. A comet's eccentricity is simply what it is, regardless of our interpretation. To read intent into it is a projection of our own desires. However, history suggests a different perspective. We routinely infer intent from mathematics whenever we recognize design. The distinction between a random rock and a crafted tool lies in its geometry. The difference between random noise and harmonious music resides in its pattern. Intent, in essence, is mathematics arranged with a specific purpose. The fundamental challenge lies in distinguishing purpose from accident, a challenge as old as the scientific endeavor itself. Atlas intensifies this challenge because its numerical characteristics resist easy categorization. Its velocity far exceeds expectations. Its inclination ensures maximum visibility. Its chemical ratios defy established norms. Each anomaly considered in isolation might be dismissed. However, collectively, they form a constellation of strangeness. The mathematics of Atlas feels deliberate, irrespective of whether it truly is. This feeling, while not conclusive proof, serves as a powerful impetus. It drives us to scrutinize more closely, to question more profoundly, and to search for patterns that we might otherwise overlook. Intent may remain elusive, but suspicion thrives in the presence of numbers that refuse to conform to predictable behavior. Ultimately, the mathematics of intent is less about definitive proof and more about exploring possibility. To even consider the notion that an orbit could be a message, that a chemical ratio could function as a signal, or that a velocity could represent design, is to expand the boundaries of inquiry. Science flourishes through such expansions. Without them, anomalies remain unexplained, and entire fields of study may never emerge. The mathematics associated with interstellar visitors might one day reveal nothing more than the inherent diversity of cosmic debris. Alternatively, it could reveal that we are not alone, and that other intelligences have utilized mathematics as a universal bridge, a common key, the one language we could not possibly ignore. Atlas, though just one object, carries the profound weight of this possibility. Its numerical characteristics are etched into orbital charts and spectral tables, immutable and undeniable. Whether these numbers are random or intentional is the fundamental question. And the very fact that we are posing this question suggests that, regardless of its origin, the mathematics has already achieved its purpose. It has compelled us to contemplate intent, to imagine the possibility of communication, and to confront the notion that the universe might not be silent, but is, in fact, speaking to us in the language of equations. When the concept of intentionally directing an interstellar object towards our solar system is proposed, The immediate objection raised by most scientists is not the feasibility of achieving such a trajectory, but rather the prohibitive cost. The sheer amount of energy required to move a celestial body across the vast gulf between stars is immense. Even a relatively modest comet, measuring only a few kilometers in diameter, contains billions of tons of mass. To accelerate such a body to interstellar velocities demands a power output far beyond anything currently conceivable for humanity. Yet Atlas appears to have been launched with an almost effortless grace, hurtling into our solar system with remarkable speed and precision. Whether its journey is a natural phenomenon or the result of deliberate intent, it prompts the same fundamental question. What would it take to summon such an object across the stars? Physics begins with the principle of momentum. To alter the path of a massive object, energy must be applied, either abruptly through a single impulse or gradually over extended periods. Natural processes achieve this through gravitational interactions. A comet passing in close proximity to a giant planet can be propelled outward, exchanging energy with the planet's orbit in a process known as a gravitational slingshot. Similarly, a star within a dense stellar cluster can eject debris at velocities of tens of kilometers per second. These natural mechanisms require no fuel or engines, relying solely on the inevitable force of gravity. However, if intelligence were involved, and the objective were not random ejection but targeted summoning, then gravity would represent but one tool within a much larger and more sophisticated arsenal. The scale of energy required is daunting. To accelerate a 1 billion ton comet to 30 kilometers per second necessitates approximately 4 times 10 to the power of 22 joules of energy, a figure roughly equivalent to the total energy output of our sun in a single second. No known technology could focus such an enormous amount of energy onto a single object. Even with advanced fusion power, antimatter propulsion, or speculative exotic drive systems, the energy requirements appear insurmountable. Nevertheless, history consistently teaches us to exercise caution. What seems impossible in one era often becomes commonplace in another. For an ancient civilization possessing technology millions of years in advance of our own, the energy barrier might not even register as an obstacle. What we perceive as an insurmountable mountain may be, to them, mere dust. One method of circumventing the immense energy problem lies not in brute force acceleration, but in the concept of leverage. Gravity itself can be ingeniously employed as a tool of intent. If a civilization possessed the capability to reposition massive celestial bodies, such as planets, stars, or even artificial megastructures, they could orchestrate gravitational slingshot maneuvers on a scale that we cannot currently comprehend. A comet could be nudged gently, then left to encounter a massive planet whose gravitational pull would then hurl it across interstellar space. Repeated nudges, coupled with successive gravitational encounters, would gradually shape the comet's trajectory until it was precisely aimed. Within this framework, the civilization would expend relatively little energy compared to the vast return gained from gravitational leverage. The cost, therefore, becomes not impossibly high, but strategically minimal. Another potential factor is time. Should one be prepared to wait for countless ages, then the endeavor of summoning across stellar distances demands considerably less energy. Subtle adjustments applied at opportune moments can, over vast stretches of time, culminate in monumental transformations. A celestial body, imparted with but a fraction of a meter per second of additional momentum, can, over millions of years, find its course altered across light years. Energy distributed thinly across extended durations significantly curtails the expenditure. An advanced civilization, planning across geological epochs, could manipulate comets with efficiencies far beyond our present comprehension. To us, such a patient approach seems unimaginable. To them, it may simply be commonplace. Nevertheless, another theoretical avenue involves technology far exceeding our current capabilities. Directed energy systems, capable of propelling objects using streams of photons or subatomic particles, could, in principle, accelerate comets without physical contact. If we can conceive of solar sails for probes weighing mere grams, perhaps they can envision photon drives for celestial bodies weighing kilotons. A comet, encased in a reflective material, could be propelled across interstellar space by powerful energy beams. The energy requirements remain colossal, yet they need not be insurmountable if harnessed at stellar scales. A Dyson swarm, capturing even a minuscule fraction of a star's output, could generate beams potent enough to steer worlds. The cost then transforms from prohibitive to routine. Skeptics rightly observe that such speculation borders on fantasy. We possess no evidence of civilizations capable of manipulating stars, no proof of Dyson swarms, nor any detection of beams influencing comets. However, the absence of evidence does not equate to evidence of absence. The universe has existed for billions of years, and any civilization that emerged millions of years prior to our own would have had ample time to master energy scales we cannot currently fathom. To dismiss this possibility is to presume humanity stands at the zenith of potential. History consistently cautions against such hubris. Every epoch has considered itself advanced, only to be dwarfed by subsequent developments, even within the confines of natural phenomena. The energy involved in such summoning reveals something fundamental. For Atlas to have reached us, it must have been accelerated eons ago, perhaps within a dense stellar nursery, or through repeated gravitational encounters with planets. The energy expenditure was undeniably real, even if unintentional. Every celestial body traversing interstellar space serves as a testament to the violent energetic processes that sculpted galaxies. Summoning across the void is not merely a matter of hypothetical alien technology, but also of cosmic nature itself. The universe teems with natural accelerators, scattering debris across light years, with a power unmatched by any terrestrial apparatus. What intelligent beings might accomplish deliberately, the cosmos achieves blindly. The critical question is whether a discernible line can be drawn between the two. Human imagination struggles to grasp such magnitudes. Our rockets transport mere tons at speeds of kilometers per second. Our probes require decades to traverse mere fractions of a light year. The notion of propelling entire comets across the vast emptiness at 60 kilometers per second strains credulity. Yet perhaps this is precisely the lesson imparted by Atlas, that we must begin to contemplate such scales, not as fanciful speculation, but as tangible reality. Summoning across the stars may not be impossible, merely unfamiliar, and familiarity commences with an inquiry into the cost. The cultural ramifications of such energy scales are equally profound. If a civilization possesses the capacity to summon across stellar distances, its relationship with the universe is fundamentally distinct from ours. To us, energy is a scarce commodity, rigorously constrained and meticulously allocated. To them, it may be abundant, virtually limitless, drawn directly from the hearts of stars. Such a civilization would not quantify cost in the same manner as we do. What appears impossible to us might be utterly trivial to them. Within that vast disparity lies the difference between perceiving oneself as solitary and recognizing the existence of cosmic neighbors. If Atlas was indeed summoned, then the price was borne by an entity that does not think as we do, one that measures power in terms far beyond our conceptual grasp. Furthermore, the question of motivation arises. If the expenditure is substantial, why incur it? Why dispatch an object across the immense gulfs between stars? The answer might reside in the efficiency of communication. Radio signals degrade, are absorbed, and can be missed. Tangible objects, however, endure. A comet traversing light years carries with it its constituent chemistry, its materials, and the potential for containing artifacts. It is an unambiguous testament. The cost may be astronomical, but so too is the potential reward, certainty. If the objective is to announce presence or deliver a message, then the price of summoning may indeed be warranted. Energy is expended, but meaning is imparted. From a human perspective, the cost of summoning transcends mere technical feasibility, delving into the philosophical. To accept that Atlas was summoned necessitates our acknowledgement of energy scales that eclipse our comprehension. Such acceptance challenges our perceived significance. If other entities can expend stellar-level power to dispatch comets, then we are not the pinnacle of achievement, but rather neophytes in a far grander cosmic game. Our position within the universe shifts from central to peripheral. The energetic outlay for summoning becomes not merely a calculation, but a confrontation. It compels us to confront possibilities we might prefer to disregard. Even setting aside any intelligence factor, the sheer numbers involved are awe-inspiring. The kinetic energy of Atlas alone surpasses anything humanity has ever controlled. It travels silently, invisibly, wielding power equivalent to billions of nuclear detonations. Whether natural or orchestrated, it serves as a stark reminder of our comparative insignificance. And if it was intentionally propelled, it is a powerful reminder that others might treat such monumental energies as casually as we might treat igniting a spark. The cost is beyond our current means, but perhaps not beyond theirs. Thus, the enduring question remains: was Atlas accelerated by the impersonal force of gravity, or by a deliberate hand? Was the immense expenditure borne blindly by nature, or consciously by an intelligent agent? We may never ascertain the definitive answer. However, in posing the question, we initiate a transformation in our thinking. We begin to perceive energy not as an absolute impediment, but as a spectrum. At one extreme lies humanity, meticulously rationing its power. At the opposite, civilizations capable of summoning across the vastness of space. The chasm separating these extremes is immense, yet not entirely beyond conception. Atlas might represent the initial intimation that this profound gulf has already been bridged. When scientists debated the arrival of Oumuamua, followed by Borisov, and then the trio of Atlas objects, a persistent thought surfaced among those open to less conventional interpretations. Perhaps these celestial bodies are not meant as messages in the conventional sense of communication, nor as probes designed to signal or convey information, but rather as silent observers. These entities are passive, unresponsive, and indifferent to whether we notice their presence, yet they are undeniably present. This is the concept that some began to refer to as the silent witness hypothesis. The notion posits that interstellar objects might function as impartial observers, dispatched not to communicate or interfere, but simply to witness, to drift into our solar system, gather information by proximity, and then depart without leaving any discernible trace of interaction. At first appraisal, the concept appears peculiar. Why would any intelligent entity undertake the formidable effort of dispatching vast quantities of mass across interstellar distances solely for the purpose of observation? Surely more efficient methods exist for observing from afar, such as radio telescopes, arrays spanning light years, or even probes stationed discreetly at the fringes of planetary systems. However, the silent witness hypothesis contends that the sheer bulk of these visitors may, in fact, serve as their camouflage. To us, they appear as nothing more than comets, indistinguishable from natural cosmic debris. And this is precisely the objective: to observe without being observed, to gather intelligence without arousing suspicion. And if the universe is a domain where survival hinges on prudence, then maintaining silence may be the most rational strategy of all. The theory draws its foundational principles from the dark forest hypothesis within astrobiology, which suggests that advanced civilizations remain reticent out of a profound fear of predation. In a universe where the intentions of other entities remain inherently unknowable, broadcasting one's presence into the void is a perilous undertaking. It is far safer to remain concealed, observing silently, than to risk exposure. If this line of reasoning holds true, then any probe dispatched to nascent civilizations, like our own, would adhere to the same principle. They would observe rather than announce. They would mimic natural celestial bodies, not artificial constructs. They would bear witness, not intervene. Hence the silent witness. Applied to Atlas, the hypothesis gains significant intrigue. Its anomalous chemical composition, its unusual velocity, and its precise timing could all be interpreted as natural occurrences. However, they could equally be interpreted as subtle signatures of a concealed function. Perhaps the elevated ratio of carbon dioxide is not accidental, but rather engineered chemistry, serving to mask sophisticated sensors or propulsion residues. Perhaps the extraordinary speed is not merely a result of natural ejection, but a deliberate acceleration engineered to ensure a flyby within humanity's observational capacity. And yet, despite all these peculiar characteristics, no discernible signal, no transmission, no attempt at communication has been detected. Silence prevails. If intent is present, it meticulously conceals itself behind a perfect imitation of natural phenomena. This pervasive silence may in itself constitute the message. To dispatch an object that does not speak is to convey that we are observing but not engaging. We acknowledge your existence but do not reveal our own. The message is not articulated through words, but through their absence. It compels the receiving civilization, in this instance humanity, to question, to speculate, and to engage in endless debate about the existence of intent. In this regard, the silent witness achieves its intended purpose. It subtly shifts perception, introduces doubt, and ignites curiosity, all without uttering a single sound. Furthermore, the question of duration is pertinent. A radio transmission persists only as long as the signal remains detectable. A broadcasting probe might be identified, but only while it is actively transmitting. A comet-like object, however, leaves an enduring record. Once it traverses our vicinity, its trajectory is permanently logged. Its very existence becomes undeniable. Even if its ultimate meaning remains elusive, the silent witness persists as irrefutable data. Even if no explicit message is conveyed, the fact of its passage endures, fundamentally altering humanity's perspective of its place within the cosmos. Silence in this context transforms into an eternal witness. Skeptics, however, assert that this theory devolves into unfalsifiability. If every interstellar object could potentially be a silent witness, then the claim becomes untestable. Without definitive signals, without tangible artifacts, there is simply no concrete evidence. Yet, it is precisely this lack of definitive disproof that sustains the idea's appeal. It cannot be definitively disproven because it operates on the realm of possibility rather than absolute certainty. The very absence of irrefutable proof is what lends it its compelling nature. Silence in this particular instance is not a weakness of the theory, but rather its inherent strength. A civilization committed to extreme caution would deliberately leave no detectable trace. To expect otherwise is to fundamentally misunderstand the premise. The silent witness theory also fundamentally reframes our expectations of extraterrestrial contact. For decades, the SETI initiative has operated under the assumption of communication, actively searching for deliberate beacons, unmistakable signals, and clear transmissions. The silent witness hypothesis proposes an entirely different paradigm. It suggests that initial contact may not involve communication at all, but rather passive observation. It posits that we may already be under scrutiny, not engaged in dialogue. The first extraterrestrial visitors may refrain from speaking until they are convinced of our nature, until they deem it safe, until they judge us ready. Within this framework, Atlas and its predecessors are not the prelude to a cosmic dialogue, but rather a quiet assessment of a civilization still in its formative stages. From a cultural standpoint, this theory is undeniably unsettling. Humans possess a preference for narratives of discovery, dialogue, and mutual exchange. The idea of being silently observed without any opportunity for response evokes a sense of discomfort. It conjures notions of surveillance, control, and manipulation. Yet, it may also accurately reflect the fundamental realities of the universe. In the natural world, observers frequently remain hidden to avoid influencing the behavior of the subjects they are studying. We strategically place cameras in forests to observe wildlife without disturbing its natural activities. We employ camouflage to discreetly observe animals in their native habitats. If intelligence beyond Earth operates under a similar logical framework, then silent witnessing may indeed be the prevailing modus operandi. We are akin to wildlife, unaware of the hidden watchers, behaving precisely as we would if left entirely to our own devices. Furthermore, the matter of patience is crucial. If Atlas represents a silent witness, then its journey to our solar system likely spanned millions, perhaps even billions of years. This level of patience far exceeds anything humanity can currently comprehend. It suggests motivations that are not driven by urgency and timelines that are not constrained by human lifespans. The witness does not hasten its arrival. It drifts silently, patiently awaiting the opportune moment when it passes sufficiently close to observe, to record, and to note before departing, leaving us with questions that may never yield definitive answers. Silence in this context is not an absence of meaning. It is meaning in its purest form. The silent witness theory aligns seamlessly with the observed lack of evidence for advanced civilizations elsewhere in the cosmos. If the universe is populated by silent witnesses rather than vocal transmitters, then the great silence we perceive is not a paradox, but a deliberate policy. We hear nothing because no one speaks. We see nothing because no one reveals themselves. All that remains are objects that traverse the void, debris unnoticed except by those who dare to harbor suspicion. And once suspicion takes root, it is remarkably difficult to fully eradicate. Every interstellar visitor subsequently becomes a subject of suspicion. Every trajectory is scrutinized for more than mere orbital mechanics. Silence fundamentally reshapes our perception, transforming perceived neutrality into latent potential. Atlas further amplifies this perception due to its anomalous chemical composition. Had it been an ordinary celestial body, its silence could have been readily dismissed. However, its peculiar anomalies compel our attention. Why such an abundance of carbon dioxide? Why such remarkable velocity? Why at this precise moment? The questions proliferate, and in their persistent lack of answers, the silence grows more resonant. Perhaps this is the intended outcome: to leave us not with certainty, but with profound doubt, to ensure that we never again gaze at the night sky without contemplating whether the debris drifting past is truly just ordinary debris. Critics will undoubtedly continue to demand definitive proof, and it is entirely possible that such proof may never materialize. However, perhaps proof is not the ultimate objective. Perhaps the silent witness exists not to convince, but to destabilize, to challenge our ingrained assumptions, to instill humility, and to remind us that the universe may not be devoid of advanced life, even if that life chooses not to speak. Silence, in this profound sense, is not an emptiness, but a palpable presence. The witness testifies without uttering a sound. Its very existence serves as the testimony. And thus, Atlas passes through silent and enigmatic, leaving us to ponder whether we have, in fact, just been observed. Whether the peculiar chemistry, the extraordinary speed, and the observed orbit are merely elaborate camouflage for some underlying function. Whether we are, at this very moment, akin to wildlife under careful study, oblivious to the hidden cameras strategically placed within the cosmic trees. The silent witness offers no explicit answers, but instead imparts an unsettling awareness that answers may not be forthcoming, and that the very sky above us may already contain them, ingeniously disguised as ordinary objects, drifting silently, watching as we watch, and recording as we record. When astronomers meticulously plotted the celestial path of the object, designated 3 Atlas, one particular detail rapidly became apparent. Its trajectory through our solar system, while seemingly arbitrary at first glance, traversed regions of the sky that held significance far beyond mere astronomical coordinates. It navigated through constellations that have long been recognized and imbued with meaning by diverse human cultures. Its track unfolded against the very same stellar patterns that guided ancient mariners and inspired countless myths. The object itself remains utterly indifferent to these human-fashioned patterns. Of course, stars are not intrinsically grouped in three-dimensional space. They are merely projected together from our specific vantage point. However, the resonance between these observed orbital paths and humanity's celestial lore invites a deeper, more profound question. Could these alignments themselves be an integral part of a deliberate design? Could interstellar visitors consciously select routes that are chosen not solely for their physical plausibility, but also for their symbolic visibility? Hidden celestial alignments may indeed hold profound meaning, even if that meaning is not immediately apparent. The notion that celestial alignments hold significance is far from novel. Ancient civilizations consistently viewed the heavens as a cosmic map reflecting divine intentions. Monumental structures like pyramids, temples, and stone circles were meticulously aligned with astronomical events such as solstices, equinoxes, and the rising of specific stars. In those historical periods, the appearance of a comet traversing a particular constellation was often interpreted as a deliberate omen. A brilliant comet observed within the constellation Leo might portend the downfall of a ruler. One appearing in Virgo could suggest an impending famine or a period of great fertility. Regardless of their objective veracity, these perceived alignments profoundly shaped historical events. Armies hesitated before battle. Rulers made significant pronouncements. And entire cultures shifted their trajectories, all influenced by the perceived meaning embedded within celestial geometry. We are inclined today to dismiss such interpretations as mere superstition. However, the underlying human impulse to find patterns and meaning in the heavens persists. Alignments capture our attention. We inherently notice when celestial paths intersect with significant patterns. An atlas, whether by chance or by design, provided numerous such intersections. Its inbound trajectory was plotted against the celestial region in proximity to Lyra, a constellation already renowned within the ongoing search for extraterrestrial intelligence. It was towards this specific sector of the sky that early SETI initiatives initially directed their efforts, detecting the first unexplained radio pulses decades ago. Although those signals remain unconfirmed, Lyra has become symbolically significant within the culture surrounding the search for alien life. The emergence of Atlas from this very same celestial vicinity did not go unnoticed by observers. It may have been a coincidence, but it was a coincidence remarkably aligned with existing cultural expectations. It represented a subtle, hidden alignment between the celestial object and a potent symbol. As Atlas continued its inward journey, its path crossed near the constellation Hercules, another celestial grouping steeped in mythology, representing strength and formidable challenges. Such associations may hold no objective significance, yet they resonate deeply with the human narrative. We interpret celestial alignments through the lens of stories. When celestial bodies appear to traverse constellations that possess particular significance, meaning seems to emerge almost automatically. This is the fundamental mechanism by which alignments operate. They superimpose physical motion onto symbolic maps, thereby creating patterns that captivate the imagination. A more profound possibility is that these alignments are not merely accidental overlays, but rather deliberate choices. If an entity wished to draw attention, selecting trajectories that intersect with regions of the sky, rich in human symbolic meaning, would represent a highly effective strategy. Even if civilizations across the galaxy do not share common constellations, they might reasonably anticipate that any intelligent observers would inevitably construct symbolic maps of the heavens. Alignments would thus serve as universal tools for engagement, not as a language in the strict sense, but as a meta-language, a recognition that any entity gazing at the stars will inevitably weave narratives around observed celestial patterns. To design a trajectory that deliberately intersects with these established narratives is to communicate through resonance. Skeptics, however, contend that the sky is densely populated with celestial alignments, and therefore any trajectory is bound to pass through some region of cultural significance. They argue that confirmation bias leads us to notice only those alignments that conform to our pre-existing expectations. Yet, even this skepticism cannot entirely negate the undeniable fact that humans are predisposed to recognize and attribute meaning to alignments. Whether intentionally orchestrated or not, these alignments matter because we imbue them with significance. And in the realm of communication, perception is paramount. If we perceive an alignment as meaningful, then its effect is achieved, irrespective of the original intent. Atlas also exhibited temporal alignments, not solely spatial ones. Its discovery occurred on July 1st, precisely midway through the calendar year. While this date holds no specific astronomical significance, it possesses a potent symbolic resonance within human culture, representing balance, the midpoint, and the turning of seasons. Temporal alignments can be as evocative as spatial ones. If a sequence of future interstellar objects arrives at similarly symbolic temporal junctures, suspicion will inevitably deepen. Patterns of alignment will begin to suggest deliberate orchestration. For the present moment, Atlas offers only coincidence, but when coincidence is repeatedly observed, it invariably transforms into evidence of design. Another dimension of alignment emerges in the realm of geometry. When the distinct trajectories of Oumuamua, Borisov, and Atlas are plotted together, their inbound vectors do not present as a random scatter, but instead form angles that can be interpreted as significant. Certain researchers have proposed that their paths, when extrapolated backward in time, converge within regions that could hint at a common origin. Others perceive deliberate geometric patterning, as if these objects were integral components of a larger, more intricate design, only now beginning to reveal itself. With only 3 data points, such claims remain highly speculative. However, should future interstellar visitors reinforce this perceived geometric pattern, then these alignments may ultimately reveal more than mere coincidence. They may in fact reveal a distinct signature. This possibility directly connects to the mathematics of intentionality. Alignments can be subtly encoded within orbital parameters. Orbital inclinations can be meticulously chosen to intersect specific celestial planes. Arguments of perihelion can be precisely tuned to ensure visibility against particular constellations. These deliberate choices would be exceptionally subtle, nearly imperceptible without rigorous analysis and plotting, but undeniably unmistakable once recognized. The message would not be overtly apparent, but rather embedded within hidden geometry. For civilizations accustomed to deciphering complex puzzles, such a subtle yet intricate message would prove irresistible. The alignment itself becomes the puzzle. Even purely natural alignments have historically exerted profound cultural influence. Halley's Comet, for instance, made its appearance in the year 1066. Its path conspicuously intersected constellations visible in Europe during the pivotal Norman conquest of England. The comet was famously immortalized in the Bayeux Tapestry, depicted as an omen and a symbol forever interwoven with this significant epoch in human history. This alignment held no inherent intent, yet it profoundly shaped perception, and subsequently, perception shaped historical events. Should celestial visitors like Atlas continue to align with cultural touchstones and symbolic celestial phenomena, their influence will resonate as prophecy, irrespective of any intended purpose. Unseen correlations require no deliberate design to function as a communication. However, if intentionality is present, the ramifications become extraordinary. To dispatch objects on trajectories that intersect with human symbolic constructs would necessitate an understanding not merely of our spatial coordinates, but of our psychological makeup. This would imply pervasive observation, an awareness of our narratives, and perhaps even foresight into our cultural progression. Such implications are nearly too immense to contemplate. Nevertheless, if these alignments persist and accumulate, we may find ourselves compelled to do so. Silence might not signify an absence, but rather a profound subtlety. It could represent the utilization of alignments as the sole guaranteed method to circumvent our skepticism. The inherent challenge lies in the fact that alignments are not objectively provable. Their existence is contingent entirely upon interpretation. A trajectory through the constellation, Lyra, is dismissed as coincidence until a sufficient number of coincidences coalesce into a discernible pattern. A discovery date at the midpoint of an event is considered chance until repetition forms a sequence. For the present moment, Atlas remains an enigma. Its alignments may be veiled messages or merely statistical inevitabilities. Yet, the very ambiguity ensures that the question endures, and once posed, it cannot be retracted. Ultimately, veiled celestial alignments are less about confirming intent and more about broadening our perspective. They serve as a reminder that the universe is not perceived in isolation, but through the prism of culture, narrative, and symbol. Regardless of whether they are intentional or coincidental, these alignments hold significance because they mold our perception. And perhaps this is the true function of visitors such as Atlas, not to convey direct messages, but to synchronize with our gaze, compelling us to observe, to question, to interpret, and to ponder whether coincidence suffices, or if something more sophisticated is at play. A peculiar paradox lies at the core of discovery. We tend to believe we find things because they are inherently present to be found. Yet, frequently, it feels as though they only truly exist for us once we acknowledge them. Until a telescope captures the faint trail of movement, an interstellar object remains unseen. This is not due to its absence, but rather because our awareness does not encompass it. This leads to a disquieting realization. What if human observation itself acts as the catalyst? What if these visitors only reveal themselves because we are actively looking? When the object designated 3 Atlas was announced on the first day of July in the year 2025, its discovery did not occur in a void. It transpired at a juncture when global astronomical networks were operating at full capacity, when machine learning algorithms were meticulously sifting through nightly data streams, and when instruments worldwide were functioning in near-perfect synergy. In earlier centuries, Atlas would have passed entirely unnoticed. Even in the middle of the 20th century, with the advent of photography and meticulous surveys, the probability of its detection would have been minuscule. Only within this precise technological epoch could such an object not only be observed, but also subjected to detailed study. This convergence raises a pertinent question. Is detection merely a matter of luck? Or does the act of observation itself somehow imbue the object with existence, at least within our consciousness? In the realm of physics, observation is not invariably a passive act. At quantum scales, the very act of measurement fundamentally alters the system, collapsing probabilities into concrete outcomes. While interstellar comets are vastly removed from the uncertainties of quantum mechanics, a philosophical parallel persists. Through our observation, we generate meaning. The object transforms from mere drifting debris into a subject of intense inquiry, from an anonymous celestial body into an interstellar emissary. Human observation alters its role, if not its fundamental nature. The trigger is not physical but cultural. By observing, we invoke the silent witness hypothesis, posited that such objects might be engineered to evade detection unless closely examined. Extending this concept, perhaps they are designed to hold significance only when noticed. A drifting mass holds no meaning for a species devoid of telescopes. However, once those telescopes come into being, the object suddenly fulfills its purpose. It instantly becomes not just detritus, but a signal. Human observation functions as the switch that activates the object's designated role. Without us, it is inconsequential. With us, it is a message. There is also the psychological dimension to consider. Prior to the arrival of Oumuamua, the concept of interstellar visitors was largely theoretical. Theories postulated their existence, yet none had ever been empirically witnessed. Following its discovery, astronomers intensified their efforts. When Borisov appeared, it was not found by chance, but rather by anticipation. Atlas followed a similar line of reasoning. Each discovery sharpened awareness, thereby increasing the likelihood of further encounters. Human observation is a cumulative process. The more we investigate, the more we uncover. In this manner, observation itself fosters the conditions conducive to discovery. The universe did not change, rather our attention did. And attention is frequently indistinguishable from reality itself. Some theorists propose an even more radical notion. What if these objects are not simply awaiting discovery, but actively responding to it? If an advanced intelligence has concealed probes within the guises of comets, those probes might only activate upon detecting observation. Telescopes emit light, radar pulses, and radio signals. To us, these are instruments for measurement. To them, they could serve as triggers. Once observed, the object might subtly alter its behavior, enough to reveal anomalies that provoke debate, but not so much as to confirm artificiality. This cycle of suspicion is sustained not by concrete evidence, but by subtle hints. In this conceptual framework, observation transcends mere detection to become active participation. By looking, we become integral to the experiment. Certain clues within the data lend credence to this unsettling notion. The anomalous acceleration of Oumuamua only manifested after meticulous tracking, as if it were revealing itself once human attention was firmly fixed upon it. Borazov reassuringly behaved precisely like a comet, almost as if it were fulfilling an anticipated role. Atlas, with its dominant carbon dioxide composition, reintroduced an element of strangeness, timed perfectly to maximize coverage by both space-based and ground-based instruments. Each object appears calibrated to the level of scrutiny available at that particular time. As our observational capabilities expand, so too does the manifestation of anomaly. It is as though these visitors are precisely tuned to our gaze. Skeptics vehemently dismiss this as egocentric fantasy. Objects, they argue, are indifferent to whether we observe them. Their orbital paths were determined long before humanity even evolved. Observation, they assert, cannot influence trajectories. To believe otherwise, they contend, is to place humanity at the very center of a cosmic drama, repeating ancient errors akin to geocentrism. Yet even the most ardent skeptics must concede that the timing feels remarkably uncanny. The concurrence between our readiness to observe and the arrival of these visitors is exceedingly difficult to disregard. Regardless of whether our observation physically triggers them, it undeniably ignites their significance. They hold importance now because we perceive them now. This is an irrefutable fact. Another perspective emerges from information theory. To effectively transmit a message, one must consider the receiver's capacity to both notice and decode it. If interstellar visitors are indeed deliberate in their actions, then they would logically need to arrive at a time when humanity is capable of observation. Otherwise, the message would be rendered futile. In this context, human observation is not merely a trigger, but a prerequisite. The visitors are engineered to coincide with our technological capabilities. Observation is not an optional element. It is an integral part of the plan. The fact that Atlas materialized when the James Webb Space Telescope, the Rubin Observatory, and other instruments were fully prepared suggests that our gaze may indeed be the operative trigger. Furthermore, there is a cultural catalyst at play. Prior to Oumuamua, the general public was not predisposed to contemplate the existence of interstellar visitors. This idea was largely confined to the domains of astronomers and science fiction enthusiasts. Now, it has become a matter of widespread public interest. News headlines, documentaries, and public debates ensure that each new celestial object captures the global imagination. Human culture itself has now become an integral component of the observational network. Even if the majority of individuals never peer through a telescope, they participate by following the unfolding narrative. Observation is not solely a technical endeavor, it is also social. And this social observation may be as significant as the scientific. A message that remains unread is meaningless. However, a message that is debated, feared, or celebrated effectively fulfills its purpose. Observation, in any form, be it scientific or cultural, activates significance. If this premise holds true, then subsequent arrivals will likely perpetuate this pattern. They will appear when humanity is not only capable of observing, but also prepared to interpret. Each new anomaly will coincide with cultural readiness, thereby propelling the debate forward. The trigger will encompass not only telescopes, but the entirety of human awareness. We will not merely see them, we will anticipate their arrival. And anticipation itself is a form of summoning. Once a civilization begins to expect visitors, every subsequent arrival assumes profound meaning. The distinction between coincidence and deliberate invitation blurs until it vanishes entirely. But what if observation genuinely influences reality? Some theorists conjecture that advanced probes might be quantum entangled, collapsing into specific states only upon detection. Others envision surveillance systems designed to remain dormant until illuminated by starlight, reflected through human instruments. In these hypothetical scenarios, our act of looking is not merely symbolic but functionally critical. We literally initiate the activation of their intended role. The object assumes its destined purpose solely because we observed it. While this notion remains speculative, it aligns perfectly with the pervasive silence we otherwise encounter. It provides an explanation for why nothing announces itself loudly, as everything awaits quiet observation. The most unsettling aspect is our inability to ascertain whether our observation is passive or actively triggering. We cannot step outside our own consciousness to test the difference. Once Atlas was observed, its meaning was irrevocably altered. Whether its intrinsic nature changed, we cannot definitively say. All we know is that prior to the first day of July, it was an anonymous entity. After that date, it became an anomaly. The dividing line is human observation, the trigger, whether physical or perceptual. Celestial objects may arrive to observe us. Extending that idea further, perhaps they only observe us once we, in turn, observe them. This represents a mutual recognition across unimaginable distances of light years. It is silent, yet undeniably real. They drift into our solar system, indifferent until our gaze falls upon them. Once noticed, they become witnesses not only to us but of us. Our observation serves as their activation. Their silence is our participation. The symmetry of this situation is unsettling, but perhaps that is precisely the intended effect. And so, Atlas continues on its trajectory, physically indifferent, yet perceptually significant. Whether summoned or accidental, it acquired meaning solely because we looked. Whether a passive fragment of rock or a disguised probe, it became a participant only when our gaze focused upon it. Human observation served as the trigger, and once triggered, the cascade of speculation, cultural interpretation, and emergent meaning cannot be reversed. Each new visitor will inevitably repeat this cycle. The universe itself may remain unchanged, but we will be transformed because the very act of seeing alters both the object and the observer. For many decades, preceding the conception of 3 Atlas within the minds of astronomers, the search for extraterrestrial intelligence, SETI, had been diligently straining its auditory sensors towards the stars. Vast arrays of radio telescopes meticulously scanned the celestial expanse. Sophisticated computers tirelessly sifted through immense volumes of data, and generations of dedicated scientists honed their skills to discern genuine signals from mere background noise. The underlying logic was straightforward. If other intelligent civilizations exist, they will inevitably communicate. And if they communicate, they will undoubtedly leave detectable imprints within the radio spectrum. Yet decade after decade, no conclusive findings emerged. The renowned WOW signal of 1977 offered a fleeting moment of tantalizing possibility, but it was never repeated. Countless potential candidates appeared, only to invariably resolve into mundane, terrestrial explanations. The universe remained silent, a silence that many began to interpret not as an absence of signals, but as a deliberate policy of concealment. When interstellar visitors began to appear in the 21st century, SETI researchers could not help but ponder whether these phenomena represented a different modality of communication, one not transmitted via radio waves, but through physical matter itself. Perhaps the pervasive static that inundated their receivers was not at all empty, but rather a form of deliberate obfuscation, while the true messages drifted unobtrusively as comets. From this perspective, SETI had been searching in the wrong location, not in terms of dedication, but in terms of its fundamental assumption. The prolonged waiting game may have been focused on deciphering words when the cosmos was, in fact, communicating through objects. The primary difficulty lies in the inherent nature of static. Radio receivers are perpetually bombarded by a cacophony of noise. Terrestrial interference, the cosmic microwave background radiation, random bursts from distant stars, lightning strikes, artificial satellites, and aircraft. To extract a genuine signal from this overwhelming noise is akin to finding a whisper in the midst of a hurricane, even if a transmission were purposefully directed at Earth. It could be buried so deeply as to be irretrievable. Many researchers have quietly acknowledged that if extraterrestrial signals exist, we may have already recorded them without realizing it. They would have appeared as mere interference, been dismissed as insignificant, and subsequently vanished into forgotten data archives. The distinction between static and signal is not absolute. It is a matter of interpretation. This notion eerily mirrors the way interstellar objects are currently being evaluated. A comet passes by, and we readily assume it is a natural celestial body. Only when a confluence of anomalies emerges, unusual chemical compositions, suspicious accelerations, uncanny temporal coincidences, do we pause and consider the possibility of something more. SETI and the study of interstellar objects are essentially mirrored endeavors. Both meticulously sift through vast fields of noise in search of subtle hints of signals. Both confront the inherent risk of false positives. Both endure criticism for pursuing seemingly coincidental occurrences. And both may be engaged in the same prolonged waiting game, peering into a silence that might not be silence at all. The protracted waiting game has profoundly shaped the culture of SETI. It is a field defined less by discovery and more by sheer endurance. Year after year, instruments register nothing conclusive. Yet, the search perseveres. Some view this persistence as futile, while others regard it as a testament to disciplined dedication. The same principle applies to interstellar objects. Each arrival may ultimately prove to be natural and unremarkable upon detailed analysis, but the very act of observation, of maintaining preparedness for the potential of anomaly, sustains the ongoing search. Waiting itself becomes the practice, and it is this practice that holds significance. When Atlas appeared, SETI researchers promptly directed their instruments towards it, with radio telescopes scanning its trajectory in anticipation of potential emissions. None were detected. However, this silence did not lead to discouragement. Rather, it deepened the intrigue. The waiting game is not defeated by silence. It is fundamentally defined by it. Silence is an expected outcome. The true challenge lies in continuing to listen regardless, in sustaining patience across years and even across lifetimes. And so, SETI incorporated Atlas into its archive of silence, Another object that conveyed no audible message, yet might have signified everything, depending entirely on one's method of listening. A growing suspicion suggests that silence itself may be a deliberate strategy. If the dark forest hypothesis holds true, then advanced civilizations do not broadcast their presence openly. They remain concealed, cautious, and reluctant to expose themselves within a potentially hostile cosmic environment. Transmitting physical objects may be a safer approach than emitting radio signals. Objects can adopt disguises, masquerading as natural celestial bodies, thus passing unnoticed and undergoing less scrutiny. The waiting game thus shifts from listening to observing, from the domain of ears to the realm of eyes. The pervasive static of the cosmos becomes less relevant than the precise geometry of orbital paths. SETI may need to redefine its mission, transitioning from a search for signals to a search for anomalies. The static persists, but the scope of the waiting game expands. The human dimension of waiting is particularly profound. Generations of scientists dedicate their entire careers to this silent pursuit. They endure skepticism, limited funding, and public indifference. They understand that the ultimate discovery may not occur within their own lifetimes. Nevertheless, they persist in their listening. This unwavering endurance itself conveys a message about humanity's inherent patience and our willingness to extend curiosity beyond immediate gratification. If extraterrestrial civilizations are observing us, perhaps this very patience is what they are assessing. The waiting game is not exclusively ours. It may very well be theirs as well. It is plausible they are waiting for us to demonstrate that we, too, possess the capacity for patience. Static also imparts a valuable lesson in humility. Every unexplained blip serves as a stark reminder of our limited knowledge. The cosmos is an immense expanse teeming with signals we cannot decipher and phenomena we have yet to comprehend. Many candidates, once deemed potentially artificial, have ultimately been identified as natural phenomena, pulsars, quasars, or transient natural events. Each false alarm has served to broaden our understanding. Static, therefore, was not empty. It was a form of education. Perhaps interstellar visitors function in a similar manner. Each one may ultimately be explained as natural, but each compels us to ask new questions, develop novel techniques, and cultivate a heightened awareness. Waiting, in both contexts, fosters growth. Nevertheless, the lingering possibility remains that within the pervasive static lies something genuine, something intentional, something we have thus far overlooked. The wow signal continues to serve as an emblem of this enduring hope. It was a single unexplained burst, lasting just long enough to tantalize, yet never repeating. For some, it represents the archetype of the silent witness, a signal that appeared only once, not to engage in communication, but to demonstrate its own potential existence. Atlas may be the physical corollary to the wow signal, a fleeting presence accompanied by unexplained anomalies, followed by silence, not a conversation, but a demonstration. The waiting game offers no definitive closure, only possibilities. If silence is indeed deliberate, then it is conceivable that the waiting game will never truly end. Perhaps our purpose is to wait, to watch, and to endure ambiguity. Maybe the true test lies not in whether we achieve discovery, but in whether we persist. Civilizations that lack patience, that demand immediate answers, may perish before they ever achieve understanding. Those that endure are the ones capable of listening through centuries of static, of watching through centuries of silence, and still possessing the motivation to recognize anomaly. Waiting, in essence, becomes a selective process. Those who cannot wait never survive to hear. This line of thought reframes the significance of interstellar visitors in profoundly unsettling ways. It is possible that Atlas was not intended to convey any direct information to us. Perhaps its purpose was to ascertain whether we were still attentive, whether we were still listening, even when nothing appeared to be said. The waiting game extends beyond the realm of radio waves to encompass physical matter itself. Atlas drifts silently past. We notice, we question, we debate. This act of noticing may represent the entirety of its intended purpose. It is a reward, not in the form of answers, but in the opportunity to demonstrate our capacity for sustained waiting. Ultimately, SETI's processing of static and the broader concept of the waiting game converge on a single fundamental truth. The universe may not communicate in the ways we anticipate. It may never offer clear signals, unambiguous messages, or definitive contact. Instead, it may surround us with ambiguity, demanding patience and exacting humility. Static is not empty. It is a challenge. Interstellar objects are not meaningless. They are intricate puzzles. The waiting game is not wasted time. It is the ultimate test itself. Whether or not Atlas constituted a message, it has already fulfilled its function by sparking our wonder and compelling us to confront silence, forcing us to decide whether we will continue listening regardless. The dark forest hypothesis posits the universe as a realm of perpetual silent tension. Each civilization, much like a hunter navigating a dense forest, conserves its energy, keeps its presence discreet, and its voice subdued, acutely aware that any audible sound could betray its location to potential predators. In such an environment, survival is inextricably linked to silence. To reveal oneself is to court annihilation. This unsettling perspective has gained considerable traction, as decades of diligent listening have yielded nothing but pervasive static. If countless stars harbor planets, and countless planets hold myriad possibilities, then the conspicuous absence of discernible signals necessitates an explanation. The dark forest hypothesis offers one such explanation. They exist, but they are deliberately concealed. And if this premise is accurate, then every unusual phenomenon we encounter must be scrutinized with extreme caution, because in a universe populated by hidden hunters, even the faintest flicker of activity might not be an accident, but rather a deliberate lure. 3 Atlas fits uncomfortably within this framework. To the majority of astronomers, it is simply another comet, albeit one exhibiting unusual characteristics. However, for those willing to entertain more ominous possibilities, its precise timing, its distinctive chemical signature, and its enigmatic behavior suggest something far more complex. It is conceivable that Atlas is not merely a visitor, but a carefully placed lure, not an act of communication, but a potential trap. A brilliant, peculiar comet appearing at precisely the moment humanity has developed the capacity for detailed analysis. It could serve as a means of drawing us out, compelling us to reveal our own presence through our reaction. The lure is our inherent curiosity. The bait is the anomaly. And the trap is whatever follows. The logic is straightforward enough. In a universe characterized by pervasive silence, the entity that chooses to speak risks everything. Conversely, the entity that listens gains a significant advantage. If a civilization wished to locate another without exposing itself, it could dispatch ambiguous objects rather than transmitting overt signals. Comets that appear natural, yet bear subtle peculiarities, warranting scrutiny. A civilization eager for knowledge would direct its instruments towards such a phenomenon, emitting radar, radio, and laser pulses. Each observation and transmission effectively becomes a broadcast, signaling presence to any potential listeners. The LER principle operates not by what is sent, but by what is elicited. Atlas might have served precisely this purpose. Radar surveys, radio scans, and comprehensive observations using the Webb telescope all generated emissions capable of traversing interstellar distances. From our perspective, these were mere scientific endeavors. However, to an observer situated in the cosmic wilderness, they were definitive proof. Earth had taken notice, revealing its location, its inquisitive nature, and its readiness. The comet itself remained passive. It needed no active role. The bait is effective because we readily take it. This perspective isn't paranoia, but an extrapolation of survival logic. In the natural world, lures are commonplace. Fish use bioluminescent appendages to attract prey. Spiders construct webs that shimmer under moonlight. Plants mimic other species to entice pollinators. The underlying principle is identical: deception through a lure. An unusual interstellar comet could function similarly. It exhibits peculiar luminescence, behaves erratically, and arrives at opportune moments. We find it irresistible to investigate. Our instruments then pierce the void, inadvertently announcing our presence. In the vast darkness, such an announcement could prove fatal. Critics contend this scenario stretches credulity too far. Why would any advanced civilization resort to such elaborate baiting when more efficient detection methods exist? Surely they could monitor electromagnetic leakage, analyze atmospheric composition, or employ technologies beyond our current comprehension. Why disguise probes as comets? The answer lies in subtlety. Our broadcast leakage is faint, diluted over light years. Atmospheric monitoring requires direct line of sight and sophisticated equipment. However, compelling us to act guarantees certainty. When we direct our most powerful transmitters at an object, the signals are robust and focused. This deliberate provocation amplifies our presence far beyond what passive observation could achieve. It manipulates us into broadcasting ourselves. The danger isn't immediate. A silently passing comet doesn't instantly summon an invasion. However, within the framework of the dark forest model, the timescales involved are immense. Detection might trigger a response only centuries or millennia later. From our viewpoint, the retaliation might never materialize. But this doesn't negate the inherent risk. Every instance of curiosity, every investigation of anomalies, escalates our exposure. Atlas might represent nothing more than another entry in a cosmic ledger of identified civilizations, a silent notation. They are present, and they are observing. This interpretation fundamentally alters the role of SETI and astronomy. Instead of cautious observation, we may be inadvertently participating in a perilous game of revelation. Each radar ping, each transmission, each attempt to probe an interstellar object could be a flare in the darkness. Scientists debate the wisdom of actively broadcasting our presence. Yet passive observation may already be an unintentional broadcast. By studying visitors like Atlas, we might already be revealing more than we realize. The lure is effective precisely because it's irresistible. Curiosity is an innate human drive, and for a nascent civilization, unchecked curiosity can be perilous. The bait hypothesis also accounts for the prevailing silence. If civilizations employ such tactics, they have no need to broadcast themselves. They can remain concealed, dispatching ambiguous visitors across space to draw others out. Silence remains the dominant strategy, broken only by these lures. And because these lures are disguised as natural phenomena, they can be dismissed or overlooked. Only the targeted civilization recognizes the anomaly, and only after it has fallen for the ruse. The cosmic expanse remains dark, its hunters hidden, while the prey inadvertently exposes itself by scrutinizing what it perceives as harmless. This viewpoint imbues Atlas's peculiarities with new significance. The unusual abundance of carbon dioxide isn't merely an odd chemical signature, it's the glittering lure, the feature engineered to attract attention. Its high velocity isn't merely a consequence of chaotic ejection, but an exaggerated motion designed to be impossible to ignore. The timing of its discovery isn't coincidental. It's bait, precisely timed for when humanity possesses the instruments to react. Each anomaly becomes an integral part of the trap, each feature a component of the design. The subsequent silence serves as confirmation. The lure has succeeded. It's crucial to understand that the dark forest model isn't born of baseless pessimism, but of logic-driven caution. If resources are limited and threats are tangible, silence is the key to survival. In such a universe, trust cannot be assumed. To reveal oneself openly is to gamble. Provoking others to reveal themselves while remaining concealed is a safer strategy. If we were in their position, we might adopt the same approach. Humanity has employed similar tactics throughout its history: traps, decoys, feints. This isn't alien behavior, it's survival behavior. The unsettling realization is that we might be the prey in someone else's strategy. However, an alternative perspective exists for the bait. Perhaps its purpose isn't to endanger, but to test. A lure might not always be predatory. It could be a means of assessing readiness, gauging curiosity, and observing a civilization's level of advancement. Atlas might not be a trap, but an examination. The anomalies could be puzzles intended to stimulate thought rather than to foreshadow doom. In the dark forest, not all hunters are killers. Some observe, evaluate, and even foster. The lure draws us out not for destruction, but for assessment. Our reaction becomes the test. Our curiosity, our patience, and our caution are the answers we provide. The bait reveals not our location, but our fundamental nature. Regardless of whether it's a trap or a test, the outcome is the same. Humanity is compelled to confront the notion that curiosity carries inherent risks, that our instruments can be both our strength and our vulnerability, and that silence is not emptiness, but a deliberate strategy. The dark forest analogy and the allure of bait serve as a stark reminder that in the immensity of the cosmos, nothing can be presumed safe, not even the comets that drift serenely past. Each might be a natural phenomenon, but each could also be something more. And the very act of observing ensures we can never again dismiss them as mere rock and ice. When an interstellar object like Oumuamua, and later Borisov and Atlas, enter our solar system, one of the primary questions astronomers grapple with is whether their trajectories are random or deliberate. The official stance consistently favors randomness, attributing their paths to ancient ejections and the impartial mechanics of gravity. Nevertheless, a persistent suspicion lingers, particularly as these visitors appear in close succession. Was our solar system merely one of countless waypoints in its eternal drift? Or was Earth specifically the intended destination? This question transcends mere mathematics, venturing into the realm of philosophy, for to entertain the possibility that Earth was chosen is to consider intent. At first glance, the probability seems astronomically small. The galaxy is vast, stars separated by light years, and planetary systems are minuscule targets against the interstellar void. To launch an object from one star and have it intersect another, even with accuracy measured in millions of kilometers, demands a precision that defies comprehension. Natural ejection is indiscriminate, scattering debris in all directions. To assume that one of these fragments would serendipitously intersect Earth's orbit is to posit a coincidence of staggering improbability. Yet improbabilities do occur. Our very existence is a testament to improbable alignments. Earth situated at the optimal distance from the Sun, water remaining stable on its surface, and conditions conducive to life converging. The universe is replete with low probability outcomes, and we are among them. Why should this phenomenon be any different? However, coincidence has its limits. The repeated arrivals of Oumuamua, Borisov, and Atlas within such a compressed time frame test those limits. And the more closely we scrutinize Atlas, the more its characteristics suggest deliberation. Its closest approach to the Sun, its perihelion distance, brought it near enough for visibility, yet not so close as to be incinerated. Its trajectory intersected the orbital plane in a manner that made detection by multiple survey instruments almost inevitable. Its velocity, though extreme, was not so high as to render it unobservable. Every aspect of its path seemed precisely calibrated for notice. If Earth was not the intended destination, then why did its orbit align so perfectly with our observational capabilities? This raises the unsettling prospect that Earth was not merely the destination, but also the intended audience, that the object was meant for us, timed for our observational window, and placed on a path that intersected our awareness. This isn't communication in the conventional sense of spoken language, but communication through geometry, a message inscribed not in radio waves, but in its trajectory. The ultimate destination was not physical impact, but perception. Earth was not to be struck, but to be made aware. Theories of panspermia sometimes posit comets as vehicles for life, drifting between stars to seed new worlds. If Atlas carried not a message but material, then Earth's arrival could signify delivery. Organic molecules, exotic chemical compounds, perhaps even engineered biological agents embedded within its icy structure could have been part of its payload. These are possibilities entertained by some researchers. The unusual dominance of carbon dioxide in its coma might be incidental, or it could be the trace of something carried within. A direct impact with Earth would be catastrophic. However, passing nearby, shedding dust and molecules into our atmosphere would be a far more subtle form of delivery. If the intent was delivery, then proximity would suffice. Influence at a distance would be adequate. Skeptics remind us that our solar system is teeming with celestial bodies, and Earth is neither the largest nor the most gravitationally influential. Jupiter dwarfs us in its gravitational pull, dominating the inward flux of comets. If Atlas were merely a random interstellar fragment, the odds would favor its capture or deflection by Jupiter. That it avoided capture and threaded its way inward to pass near Earth is improbable. Improbable, but not impossible. Probability does not preclude coincidence. However, when coincidence aligns with apparent meaning, suspicion naturally arises. An alternative explanation posits that Earth's destination may not signify Earth specifically, but rather intelligence in general. A probe sent to the solar system might not necessarily aim for our small planet, but for the inner system as a whole, where detection is most likely. While Earth hosts our observers from the perspective of a designer, any inhabited world within range would serve. Earth feels central to us, but to an external intelligence it might be incidental. The true destination was awareness, wherever it might exist. That it was us is a coincidence only in the sense that we are the ones here to witness it. There is also the matter of timing. If Atlas was ejected naturally, its journey would have spanned millions of years. It's inconceivable that any entity could aim for Earth with such precision across such vast temporal scales, at least not without technological capabilities far beyond our current understanding. To believe Earth was the intended destination implies foresight on geological timescales. However, civilizations potentially millions of years older than ours could conceivably predict planetary orbits across such expanses. With sufficient knowledge, precision becomes attainable. To them, our tiny world might pose no greater challenge to target than a star does to us. The scale of time fundamentally alters what is feasible. The improbable becomes trivial when patience is infinite. Nevertheless, the possibility that Earth was specifically chosen carries significant weight, even if it remains unproven. It shifts our perception of the object, transforming it from a random wanderer into a potential envoy. It compels us to consider motives. Why us? Why now? If Earth was the destination, what was the intent of its senders? Was it a message of curiosity, a warning, a test, or something more profound? The silence of Atlas leaves these questions unanswered, yet the very act of posing them reshapes our perspective. Silence becomes less empty when intent is a possibility. Another dimension to this question involves cultural readiness. Perhaps Earth was the destination not due to its spatial location, but because of its developmental stage. A civilization might monitor nascent species and select moments when they reach certain milestones. The advent of radio communication, the development of spaceflight, the establishment of global observation networks. Earth in the year 2025 aligns precisely with such a profile. We are sufficiently advanced to detect such phenomena, yet not so advanced as to pose a significant threat. This presents a perfect window for a flyby, a silent encounter that leaves us aware, but not capable of immediate retaliation. If this was the intended plan, then Earth was not a target of convenience, but a target of deliberate design. Skeptics counter that this interpretation represents anthropocentric projection, placing ourselves at the center of events that are likely random. However, history cautions us against dismissing uncomfortable possibilities. We once believed Earth was the center of the universe, only to later discover otherwise. Perhaps now, in dismissing Earth as irrelevant, we risk overlooking the possibility that it was indeed chosen. Neither arrogance nor humility guarantees truth. The only certainty is that we must remain open to both possibilities. The most sobering contemplation is that Earth was indeed the intended destination, but not for communication, not for delivery, and not for testing, but for cataloging. Atlas could be one of numerous probes dispatched across the galaxy, each passing by inhabited worlds, logging their existence and continuing its journey. Earth might simply be another entry in a cosmic ledger of life-bearing planets. The objective was not conversation, but a census. The universe may not necessarily desire to speak, but it may wish to know, and the act of knowing may be sufficient. Whether or not Atlas was deliberately aimed, the notion that Earth was the destination cannot be entirely dismissed. Its trajectory, its timing, and its anomalies collectively ensure that the question will persist. Perhaps it was chance, perhaps it was design, or perhaps a confluence of both. But the very act of inquiry positions us in a novel role. We are no longer mere passive observers of comets. We are potential participants in something far grander, something that regards Earth not as incidental but as chosen. And whether chosen by chance or by deliberate will, the outcome remains the same. Earth acquired significance because Atlas passed through its vicinity, and we took notice. The debate between chance and design has shadowed every interstellar visitor since Oumuamua first surprised astronomers in 2017. When something unusual appears, the human mind instinctively diverges into two lines of reasoning. On one side lies coincidence, the belief that improbable events eventually transpire given sufficient time and opportunity. On the other side lies intention, the suspicion that improbable events are improbable, precisely because they are orchestrated. In the case of Oumuamua, Borisov, and Atlas, this tension is more pronounced than ever. Atlas's chemistry seems excessive, its speed exaggerated, and its timing uncanny. Was it chance or design? Science conventionally favors chance, with natural explanations serving as the default. A comet is considered a comet until proven otherwise. If its chemistry appears strange, perhaps our models are incomplete. If its speed is high, perhaps it was violently ejected from a chaotic stellar nursery. If its timing seems unlikely, perhaps we simply underestimated the true frequency of interstellar debris. Each anomaly possesses a plausible natural explanation, even if that explanation strains the limits of probability. Scientists are trained to resist attributing design unless the possibility of chance has been exhausted. This is the more conservative approach, less prone to leading to misconceptions. Yet, conservatism does not always equate to truth. Chance itself manifests in various forms. In one sense, it represents randomness, the uncoordinated dispersion of events across space and time. In another sense, it signifies inevitability, the concept that given infinite opportunities, even rare events, are bound to occur eventually. Interstellar comets are infrequent occurrences. However, the galaxy is vast. Billions of stars eject trillions of fragments. Sooner or later, some of these fragments are bound to cross our path. The fact that 3 have done so in less than a decade may simply reflect the law of large numbers, finally becoming apparent in our observational data. From this perspective, there is nothing particularly remarkable about Atlas. It is mere debris, nothing more. Chance alone explains it. However, design offers a contrasting framework. Instead of randomness, it perceives pattern. Instead of inevitability, it discerns intent. The sequence of visitors, Oumuamua, anomalous, Borisov, ordinary, Atlas, extreme, forms a rhythm that feels too deliberate to be blind. Each escalation appears crafted to capture our attention without providing a definitive resolution. This very structure suggests orchestration. If an entity wished to engage a nascent civilization cautiously, gradually piquing its curiosity without inciting panic, this is precisely how they might proceed. In this context, design is not proven, but feels compelling. Human intuition gravitates toward it because we are inherently predisposed to recognize patterns. The crucial question is whether these perceived patterns are genuinely present. The interplay between chance and design is further complicated by perception. To astronomers, probability is a matter of calculation. To the general public, it is a matter of impression. When informed that Atlas's velocity is unusual, most individuals interpret this as deliberate. When told its chemistry is extreme, they perceive intention. Rarity does not equate to impossibility, but human psychology often treats rarity with suspicion. This divergence in perception fuels much of the debate. Scientists advocate for chance because mathematical frameworks support it. Observers argue for design because intuition insists upon it. Both viewpoints possess validity in their respective domains, but they lead to vastly different interpretations of the same object. Consider the chemical composition. Atlas's coma was dominated by carbon dioxide to an extent unprecedented in known solar system comets. By chance, this could reflect a different formation environment, one where carbon dioxide ice was abundant and stable. The galaxy harbors diverse stellar systems, and not all are necessarily identical to ours. Yet, by design, this could represent an exaggeration intended to stand out, to provoke notice, which seems more plausible. Chance requires us to accept that our first 3 interstellar visitors coincidentally exhibit maximum diversity: 1 dry, 1 ordinary, and 1 chemically extreme. Design necessitates our belief that someone deliberately curated this sequence. Neither explanation is entirely comfortable, yet both remain within the realm of possibility. The same logic applies to velocity. By chance, Atlas might have been ejected from a dense stellar cluster where chaotic interactions fling objects outward at high speeds. By design, its extreme velocity could have been chosen to demonstrate capability, to test the limits of our observational prowess, or to ensure we could track an object moving so rapidly. Once again, both explanations align with the available data. The fundamental difference is philosophical. Chance upholds a universe characterized by indifferent chaos. Design introduces intelligence, and intelligence implies motive. Choosing between them is tantamount to choosing between 2 fundamentally different visions of reality. Timing further complicates the issue. Oumuamua arrived shortly after the deployment of wide-field sky surveys capable of detecting it. Borisov followed when astronomers were actively anticipating a second visitor. Atlas appeared when the James Webb Space Telescope was fully operational, enabling chemical analysis with unprecedented sensitivity. By chance, this could all be mere coincidence, a fortunate alignment between technological advancement and celestial events. By design, it could represent deliberate calibration, with objects timed to appear when humanity possessed the means to observe them, escalating in complexity as our tools improved. To believe in chance is to believe in fortune. To believe in design is to believe in choreography. Once again, the evidence supports both interpretations. Perhaps the true complexity lies in the fact that chance and design are not mutually exclusive. A naturally ejected object could be intercepted, subtly altered, or guided to ensure its arrival. Random fragments might be curated into specific patterns. Design may not involve creation ex nihilo, but rather the manipulation of existing chance, shaping it subtly, guiding it gently. This hybrid possibility complicates the debate. If Atlas is partly a product of chance and partly of design, then neither explanation alone is sufficient. We must consider layered scenarios where randomness provides the raw material and intent provides the direction. This possibility is challenging because it defies simplicity, yet reality often does. The history of scientific discovery repeatedly illustrates the emergence of such tensions. The celestial phenomenon of lightning, once perceived as a deliberate act of the divine, later came to be understood as a mere electrical discharge of nature. Similarly, maladies were once attributed to curses, only to be later explained as the random intrusion of pathogens. Yet with each instance, a more profound comprehension has unveiled an underlying complexity. Lightning, while adhering to the principles of physics, can still be initiated by human constructions. Illnesses, though governed by biology, can be significantly impacted by human conduct. Thus, chance and deliberate design are often intertwined. It is conceivable that extraterrestrial visitors are not fundamentally different. They might be natural cosmic detritus, yet shaped, timed, or selected for reasons yet undiscovered. A further dimension to this discussion involves humility. To posit design implies the existence and actions of other entities. To assert chance suggests our solitude and the indifference of events. Both viewpoints carry inherent risks. A belief in design may lead to unwarranted projection and anthropocentrism, inferring intelligence where none exists. Conversely, a belief in chance can foster arrogance, dismissing possibilities that transcend our current comprehension. Neither extreme offers complete security. The challenge lies in maintaining a balanced perspective, considering both possibilities without premature commitment. The case of Atlas necessitates this equilibrium, as its anomalies defy simple dismissal, yet fall short of definitive proof. From a societal viewpoint, the notion of chance offers a degree of solace. If Atlas is a random occurrence, then the universe operates predictably, absolving us of the need to fear concealed motives. Design, conversely, introduces disquiet. If it was intentionally directed, then an agent was responsible. If it conveyed a message, then a sender existed. If it served as a lure, then an observer awaits. The distinction is existential. Chance preserves our isolation. Design introduces companionship, whether desired or not. Humanity instinctively oscillates between these two poles, favoring one over the other, depending on whether we yearn for meaning or dread intrusion. The future may ultimately resolve this quandary. If numerous interstellar visitors are detected and their characteristics appear randomly dispersed, chance will be validated. Should patterns emerge and persist, design will gain credence. For the present, with only 3 documented instances, both explanations remain plausible. The interplay between chance and design has yet to be definitively ascertained. However, even within this uncertainty, the question itself possesses a transformative quality. It compels us to perceive the cosmos through a different lens, to weigh probability against possibility, and to keep the door ajar for intelligence without precipitously closing it. Atlas embodies this inherent tension. Its numerical data could be attributed to chance, yet it evokes a sense of design. Its peculiarities might be random, but they hint at purpose. Its temporal occurrence could be coincidental, yet it resonates with deliberate choreography. Regardless of whether we lean towards one explanation or the other, the outcome is consistent. We are drawn into deeper contemplation. Whether driven by chance or design, the visitor has already instigated a change within us. And perhaps that very change redefines the core issue. The universe is immense, yet it does not operate without inherent rhythm. Celestial bodies traverse the galaxy in orbit. Planetary bodies align in predictable cycles. Biological rhythms pulse like cosmic chronometers. Patterns recapitulate across scales, both microscopic and grand. And civilizations, if they exist, would undoubtedly perceive these patterns just as we do. A segment of researchers posits that occurrences we label as coincidence might in fact be something more profound, a synchronization of events meticulously arranged to coincide, creating opportune moments when attention becomes unavoidable. The appearance of 3 Atlas reignites this very possibility. Perhaps its timing was not a random happenstance nor a mere quirk of chance, but rather an integral part of a grander orchestration, a cosmic synchronization intended to manifest precisely when we were sufficiently prepared to perceive it. Synchronization stands as one of the most effective methods for intercommunication across vast cosmic distances. In musical compositions, rhythm unifies disparate instruments. In digital systems, clock signals maintain process alignment. In communication protocols, synchronized pulses are essential for rendering meaning comprehensible. If civilizations aspire to coordinate their actions across interstellar gulfs, they might leverage the universe's inherent rhythms as their temporal anchors. Pulsars, supernovae, the alignment of planets, all are predictable phenomena observable across space. To synchronize an action with one of these events is to ensure that any observer would take notice. If Atlas materialized in sync with such a rhythm, its appearance may not have been accidental at all. Consider the precise timing of its discovery. The 1st of July 2025, falling precisely at the midpoint of the calendar year. While human calendars are arbitrary constructs, the alignment with a temporal midpoint carries significant symbolic weight. To us, it suggests equilibrium, transition, and symmetry. It might be coincidental, or it might be by design. Civilizations anticipating the trajectory of human cultural development might be aware that we measure time in this manner, and that such symmetry would not go unnoticed. Synchronization does not necessarily require a physical manifestation. It can also be cultural, employing our own temporal frameworks as the stage. Atlas arrived at a juncture when symmetry was readily apparent to us, and symmetry is seldom overlooked. More intriguingly, certain astronomers observed that Atlas's trajectory towards our solar system temporally aligned with a series of significant cosmic occurrences. Gravitational wave detections, stemming from distant celestial mergers, intense gamma-ray bursts, and even the consistent pulses emanating from specific millisecond pulsars, all coincided within mere months of its appearance. Individually, each event is a natural phenomenon, but collectively, this cluster of occurrences forms a backdrop of cosmic rhythm against which Atlas's arrival appears remarkably and perhaps deliberately timed. Synchronization, though perhaps not exact, is certainly suggestive. It's as if the cosmos was beating its drums, and a visitor stepped precisely into that rhythm. Skeptics contend that such observed patterns are an inevitable consequence of the sheer volume of events occurring in the universe. They argue that connecting any single event to Atlas constitutes cherry-picking, drawing artificial lines between disparate points. Yet, historical evidence demonstrates that synchronization is often the linchpin of discovery. The transit of Venus, synchronized with an 18th century global undertaking to determine the Earth's size, comes to mind. The discovery of pulsars coincided with the proliferation of radio astronomy. Events that overlap tend to be etched in collective memory, while isolated incidents tend to fade. Even if unintentional, synchronization possesses the power to amplify meaning. Atlas's arrival amidst other celestial rhythms elevated it beyond a mere object. It transformed it into an integral part of a larger pattern. Synchronization may also occur across different civilizations. If multiple sentient species synchronize their actions with predictable cosmic events, those events then transform into markers of coordination. For instance, a pulsar that emits a pulse every millisecond serves as a galactic clock, visible across the entire Milky Way. To launch a probe, transmit a signal, or initiate an action in synchronization with that pulsar guarantees that any entity capable of observation would recognize it as a deliberate act. The rhythm becomes the conduit, and the alignment, the message itself. If Atlas was synchronized with such a cosmic timing mechanism, it might have been part of a network of events beyond our current comprehension. Another facet of this concept is psychological. Humans are inherently drawn to patterns. We find it difficult to resist them. Synchronization intensifies this innate tendency. When events converge, we tend to ascribe meaning, even if no actual significance exists. Civilizations aiming to pique curiosity would be acutely aware of this. By timing their arrivals to coincide with cosmic or cultural rhythms, they ensure they capture attention. Even the most ardent skeptics find it difficult to dismiss such apparent synchronicity outright. The perception of coincidence weakens considerably when symmetry is pronounced. And in the realm of communication, perception is paramount. If we perceive synchronization, then the intended message succeeds, irrespective of whether it was deliberately orchestrated. Atlas also demonstrated synchronization with humanity's technological readiness. The James Webb Space Telescope had just concluded its initial major observation campaigns. The Vera C. Rubin Observatory was on the cusp of commencing full survey operations. The global coordination of astronomical data had reached unprecedented levels of sophistication. The timing was, therefore, exceptionally opportune. Arriving any earlier would have resulted in less refined data. Arriving any later might have meant becoming just one among many discoveries. Arriving at this juncture, coinciding with the zenith of human observational capabilities, ensured maximum impact. This represents perhaps the most compelling form of synchronization, not with cosmic clocks, but with humanity itself. Civilizations need not synchronize with celestial pulses if they can synchronize with observers. Atlas seemed to possess an awareness of when to arrive, and that timing made its presence impossible to overlook. Some theorists extend this concept even further, envisioning synchronization not merely across disparate events, but across entire civilizations. It is conceivable that interstellar visitors like Atlas are not exclusively targeted at Earth, but are instead components of an elaborate cosmic choreography wherein multiple civilizations receive analogous objects concurrently. This could manifest as a wave of synchronized arrivals sweeping across the galaxy, with each visitor appearing precisely when a civilization reaches a threshold of readiness for detection. If this scenario holds true, then we are merely participants in a larger unfolding event, a synchronization of awareness. Each species tends to believe itself unique and special. However, in reality, each may be but a single node within a vast, coordinated cosmic rhythm. The arrival of Atlas might represent our initiation into this subtle, underlying cadence. This vision, while almost impossible to empirically test, possesses a compelling internal logic. Synchronization represents the sole universal method for coordination across interstellar distances. Direct communication is constrained by the speed of light, but synchronization empowers independent civilizations to align their actions without direct contact. By tethering their activities to predictable cosmic occurrences, they ensure a degree of coherence. If Atlas was part of such a synchronized event, then its profound significance lies not solely within our own context, but in the shared timing with entities we cannot perceive. A cosmic phenomenon we initially perceived as natural may in fact be the metronome of galactic communication. The unsettling implication is that we might not be the intended audience at all. While Atlas may have been directed towards Earth, Earth itself might not occupy a central position. The synchronization might be with something entirely different: a distant pulsar, a stellar merger, or a galactic cycle. We could be incidental observers of a much grander event. Our role might be peripheral, yet nevertheless meaningful. The visitor draws us into a rhythm that is not inherently ours, but we inevitably feel ourselves a part of it. Synchronization functions effectively because it cultivates an illusion of inclusion. Even if we are not the primary target, we become ensnared within the pattern. And it is this pattern that compels our engagement. Ultimately, synchronization effectively blurs the demarcation between chance and deliberate design. Isolated coincidences can be readily dismissed, but repeated coincidences that align with discernible rhythms demand serious consideration. Atlas did not arrive in isolation, but within a rich context, the context of our technological advancement, our cultural landscape, and our cosmic environment. Whether by design or by chance, it became synchronized with multiple layers of meaning. This synchronization might be illusory, but the illusion does not diminish its impact. In the realm of communication, perception is reality, and synchronization fundamentally ensures perception. If the cosmos communicates, it may not do so through spoken words or explicit signals, but rather through timing. It may synchronize events across scales that we are only beginning to apprehend, employing rhythms that we are just starting to recognize. Atlas might be a single beat within that grand rhythm, fleeting yet unforgettable. Its true message may not reside in its chemical composition or its orbital path, but in its precise timing, its synchronization with us, our instruments, and our readiness. Cosmic synchronization events could constitute the hidden language of the galaxy, awaiting our attention. And once noticed, we will never again perceive silence as empty. When astronomers initially examined the coma of 3 Atlas, the data seemed to hint at something fundamentally anomalous. Most comets within our solar system release water vapor upon warming, with carbon dioxide and carbon monoxide contributing in lesser quantities. However, Atlas presented an inversion of this typical ratio. Carbon dioxide predominated to an unprecedented degree, overshadowing water and leaving the scientific community perplexed. Initially, the prevailing explanation centered on the concept of natural diversity. It was hypothesized that Atlas might have formed in a significantly colder region than any of our native comets, thereby preserving volatile carbon dioxide while water remained locked in an icy state. Alternatively, it was suggested that the comet could have been ejected prematurely from its home system, carrying with it a chemical composition previously unobserved. While these are scientifically sound hypotheses for some, this anomaly sparked a more intriguing possibility. Could the very chemistry of the object be a form of deliberate enticement? Could an interstellar visitor bear not merely atoms, but intent encoded within its very composition? This line of reasoning begins with the inherent universality of chemistry. Wherever matter exists, chemical interactions adhere to immutable laws. The spectral signature of carbon dioxide, for instance, remains consistent whether observed here on Earth or in the most distant galaxies. Similarly, the emission lines of hydrogen are constant and recognizable to any observer equipped with appropriate instrumentation. This intrinsic universality renders chemistry an ideal medium for communication. If one were to endeavor to transmit a message across interstellar distances, it could be embedded within specific ratios of gases, unique isotopic abundances, or combinations that defy natural formation processes. The message would not be conveyed through words, but through numerical data, carried not by sound or light, but by the very molecules themselves. To capture attention, chemistry alone could suffice. The overwhelming dominance of carbon dioxide in Atlas's coma might represent such a summons. Not a message in the conventional sense of language, but a signal intended for emphasis. By exaggerating a specific chemical signature, the object ensured it would be noticed. Astronomers could not afford to ignore it. The data necessitated the development of new theoretical models, demanded explanations, and ignited considerable debate. This is, in essence, the purpose of a summons: to draw attention, to provoke focused consideration. Whether intentionally orchestrated or not, Atlas achieved this objective. Through its chemistry alone, it beckoned humanity's curiosity. This observation broadens the scope of possibility. Perhaps all interstellar visitors are not merely inert debris, but deliberate carriers of chemical messages. Some might exhibit anomalies in their gas ratios, others in their isotopic makeup, and still others in the presence of unexpected compounds. Each anomaly could be attributed to chance, or each could be the product of design. If the latter, then the very chemistry serves as a beacon. Unlike radio signals, which can attenuate over distance and require complex decoding, chemical signatures, once delivered, remain remarkably persistent and are impervious to distance. A comet's coma effectively becomes a broadcast of molecules, readable by any civilization possessing the capability for spectroscopic analysis. Chemistry thus transforms into the medium of the message. Skeptics, however, maintain that a wide range of chemical diversity is to be expected. Star systems vary considerably in their elemental composition, their thermal environments, and their historical formation processes. To anticipate that all comets should resemble those native to our solar system is a parochial viewpoint. Atlas, they argue, may simply reflect the chemical environment of a different stellar system. Nevertheless, even skeptics concede that extreme anomalies are potent attention grabbers. And that, fundamentally, is the point. Intentional or not, unusual chemistry functions as a signal. It summons precisely because it deviates from expectations. In a galaxy teeming with natural variation, exaggeration becomes virtually indistinguishable from deliberate design. The outcome remains the same. Observers cannot overlook it. Consider the potential for encoding information through isotopic variations. Ratios of carbon-12 to carbon-13, or oxygen-16 to oxygen-18, can reveal the conditions under which celestial bodies formed, but they can also be deliberately manipulated. A probe masquerading as a comet could harbor isotopic ratios that are physically impossible under natural circumstances, thus unequivocally pointing to artificial origin. While we have not yet conducted such detailed isotopic analysis on Atlas, future interstellar visitors may compel such investigations. If a comet arrives bearing isotopic abundances far outside naturally occurring ranges, the argument for a chemical summons will become irrefutable. The molecules themselves will bear witness. Furthermore, there exists the possibility of utilizing complex molecular structures. Natural processes tend to produce relatively simple molecules: water, carbon dioxide, methane, ammonia. Life, on the other hand, leads to complexity: amino acids, nucleotides, proteins. If an interstellar visitor were to carry complex organic molecules in quantities exceeding what random processes could produce, it could function as a summons, not communication in the sense of a dialogue, but in the sense of provocation. Humanity would be unlikely to disregard such a discovery. It would instantaneously revolutionize our understanding. The chemistry would summon not merely curiosity, but an entirely new worldview. While Atlas did not exhibit such intricate complexity, its inherent strangeness points toward this very possibility. If subsequent visitors escalate these anomalies, displaying progressively more elaborate chemistry, the case for deliberate design will strengthen. Each would represent a sequential step, a series of chemical summonses designed to draw us deeper into awareness. Initially, anomalous ratios, then unusual isotopes. Finally, complexity of our exceeding that achievable through abiotic processes. This progression would be designed to ensure attention without overwhelming the observer, guiding curiosity incrementally. If this represents deliberate design, it is characterized by subtlety, patience, and caution. Chemistry would serve as both language and a gentle restraint, carefully guiding us forward. Another perspective emerges from historical observation. Humans have long associated chemistry with summons, even if unconsciously. Alchemists sought hidden messages within elements, believing that the transformation of matter revealed profound truths. Chemists in the 19th century perceived periodicity as an expression of cosmic order, a fundamental structure inviting interpretation. Biologists view DNA as the ultimate message written in molecular form, carrying the very instructions for life. In each of these instances, chemistry was not perceived as neutral, but as inherently communicative. Atlas aligns with this historical lineage, summoning our attention not through audible sound or visible light, but through its inherent chemical properties. It continues a tradition that predates science itself, a tradition wherein matter is understood as message. Skeptics caution that such interpretations risk overreach, suggesting that perceiving communication within chemistry might be a projection of our own desires. The universe is replete with anomalies, and the vast majority possess natural explanations. However, the counter-argument is that effective communication must rely on universals, and chemistry is undeniably universal. If intelligent life exists beyond Earth, it would undoubtedly comprehend that molecules carry inherent meaning. To employ chemistry as a means of summons is not an anthropocentric act. It is a pragmatic strategy. The crucial question is not whether chemistry is capable of communication, but rather whether we can reliably distinguish between natural variation and deliberate emphasis. This distinction may well define the trajectory of astronomical study in the coming century. The prospect of summoning through chemistry also intersects with the concept of panspermia. If comets can indeed transport molecular components to planets, then interstellar visitors might deliberately carry the fundamental building blocks of life. Atlas may not only have summoned our attention, but also contributed material. Its dispersed dust particles might enter Earth's atmosphere, seeding new chemical reactions. We may never definitively ascertain whether those molecules originated naturally or were intentionally selected, but the ultimate effect remains the same. Chemistry transcends its role as mere summons and becomes an instrument of influence. The boundary between communication and delivery becomes blurred. The molecules themselves serve as both message and medium. From a cultural perspective, chemical summonses carry significant weight because they are perceived as objective. Numerical data derived from spectral analysis cannot be dismissed as mere illusion. Ratios are not ambiguous. They are as concrete as the laws of physics permit. Nevertheless, interpretation remains a fluid process. We might observe an anomaly and attribute it to chance. Alternatively, we might perceive that same anomaly and suspect deliberate design. Chemistry summons us not by providing definitive answers, but by compelling us to make a choice. Do we rationalize it away as a random occurrence, or do we entertain the possibility of intentionality? In either case, we are drawn into a state of reflection. That is its inherent power. If Atlas was a natural phenomenon, then its chemistry serves as a potent reminder that the universe is far richer and more complex than we had previously imagined. If Atlas was deliberately designed, then its chemistry represents a signal specifically intended for us. Regardless of its origin, chemistry has successfully summoned us. It has compelled us to observe, to measure, and to engage in debate. It has deepened our awareness of the phenomenon of interstellar visitors, ensuring that any subsequent arrival will be subjected to even more rigorous scrutiny. While summoning through chemistry may not constitute definitive proof of design, it undeniably demonstrates its effect. In that regard, Atlas has already succeeded, irrespective of its origin. The broader lesson to be gleaned is that the universe may not communicate through conventional language. It might not dispatch explicit signals or direct broadcasts. Instead, it may summon us through anomalies, through the subtle language of chemistry, through the quiet insistence of molecules that do not conform to our established models. Atlas was one such summons. The next may prove to be even more extraordinary. Each will call us to heightened attention. Each will compel us to expand the boundaries of our understanding. Each will test our willingness to entertain possibilities previously considered improbable. The chemistry is the summons, and the summons is sufficient. The enduring question that arises after the analysis of 3 Atlas and its peculiar chemical signature is not merely whether it summoned us, but what consequences might follow if we respond. Our inherent curiosity has driven us to study, to measure, and to speculate. However, curiosity is not a passive state. It is inherently active. Every observation we make, every radar pulse we transmit, every communication broadcast towards a passing celestial object is not merely the passive gathering of information. It is, in effect, information being sent by us. While this might seem benign, a fundamental aspect of the scientific process within the broader context of the cosmos, such actions could carry inherent risks. Answering a call is never a simple undertaking, and it is rarely devoid of repercussions. For many decades, scientists have engaged in vigorous debate regarding the prudence of actively messaging extraterrestrial intelligence, a practice known as METI, Messaging Extraterrestrial Intelligence. SETI, Search for Extraterrestrial Intelligence, in contrast, is a passive endeavor. METI, however, involves actively broadcasting signals, thereby explicitly declaring Earth's presence to any potential listeners in the vastness of space. Proponents contend that any civilization advanced enough to detect us has already registered Earth's telltale signs, such as the oxygen in our atmosphere and the stray signals from our technology. They argue that broadcasting is merely an acknowledgement of the unavoidable. Conversely, critics posit the opposite, emphasizing that maintaining silence ensures our safety. They caution that announcing our presence in an unknown universe could lead to dire consequences. Occupying the space between these viewpoints is a profound uncertainty, and it is into this ambiguity that every interstellar object we scrutinize emerges. When radar sweeps across a celestial body like Atlas, its signals disperse into the vastness of space. Likewise, radio telescopes, when sending out calibration pulses, send echoes far beyond our planet. While these transmissions may not possess enough power to traverse the entire galaxy intact, they nevertheless journey outward. Within our immediate cosmic vicinity, they might be perceptible. If Atlas is a natural phenomenon, then nothing changes. However, if Atlas is an artifact of intelligent design, then those radar beams could have been intercepted, noted, and logged. In that instant, we would have inadvertently responded. The peril is not theoretical, it is immediate. Every scientific endeavor becomes an act of unveiling. The risks associated with responding hinge on assumptions about the nature of extraterrestrial intelligence. If the dark forest hypothesis holds true, then universal silence is the established protocol. Any signal becomes a beacon, and beacons attract attention. Within such a metaphorical forest, responding to a summons is akin to inviting danger. The call could be genuine, or it could be a lure, but the risk remains constant. Once a response is sent, the sender ascertains your location. The danger might not manifest for decades or even centuries, yet the exposure is irrevocable. A transmission, once released, cannot be recalled. The risk is permanence. Nevertheless, abstaining from a response carries its own set of dangers. If a summons is genuine, our silence might be interpreted as a lack of interest, a failure to acknowledge, or even outright hostility. A civilization attempting a tentative initial encounter might anticipate some form of acknowledgement, a sign of awareness. The absence of such a signal could lead them to dismiss Earth as unprepared or unwilling. In that scenario, the risk of responding is peril, but the risk of not responding is isolation. The choice is not between risk and safety, it is between distinct forms of risk. Atlas exacerbates this quandary by embodying ambiguity. Were it obviously artificial, we could deliberately choose whether or not to engage. Were it clearly natural, the question itself would be moot. However, in this state of uncertainty, we are compelled to act without clear direction. Every observation we conduct may already constitute a response, regardless of our intentions. Every moment of silence we maintain might already be perceived as a reply. We find ourselves ensnared in a communication paradox. To act is to risk, and to refrain is also to risk. The sole certainty is that risk is unavoidable. Human history offers sobering parallels regarding encounters between civilizations. When disparate human societies made contact on Earth, the outcomes were seldom equitable. The more technologically advanced often overwhelmed the less prepared, even unintentionally. Diseases spread, resources were plundered, and cultures underwent profound transformations. Responding to a cosmic summons could replicate this pattern on a galactic scale. Even if the originating civilization harbors no malicious intent, their mere presence could destabilize us, overwhelm us, and alter us irrevocably. The risk extends beyond predation to encompass disruption. However, human history also showcases the inverse. Encounters have facilitated exchange, enrichment, and the continuation of existence. And ideas, technologies, and cultures have coalesced, creating novel possibilities. The peril of responding to extraterrestrial calls is not solely negative. It carries the potential for transformative benefits. The fundamental danger lies in our inability to predict which outcome will prevail. Once initiated, the path is irreversible, and control is relinquished. This loss of control is perhaps the most profound risk of all. Furthermore, the question of intent arises. If Atlas was intentionally dispatched, then its senders are already aware of our existence. They may have orchestrated its arrival to coincide with our perceived readiness, ensured its visibility, and perhaps even incorporated anomalies designed for our discovery. In such a case, responding might not introduce new dangers, but merely confirm what is already known. Yet risks persist. Confirmation could precipitate escalation, leading to more direct encounters and intensified scrutiny. Each step deepens our entanglement, increasing our vulnerability. Risk escalates even in cautious contact scenarios. Some argue that responding is inevitable. Humanity, by its very nature, is not a silent species. We inadvertently broadcast through every technological act. Our cities emit infrared radiation. Our communications bleed into space, and our spacecraft leave behind physical traces. To believe we can remain unobserved is an illusion. From this perspective, the risks of responding are not novel. They have always been present. Atlas merely sharpens our awareness of a reality that has existed for a century. We are already visible. The pertinent question is not whether we should respond, but whether we should persist in the illusion of having not already done so. Nevertheless, inevitability does not absolve us of responsibility. Even if exposure is unavoidable, the manner of our response matters. Reckless broadcasting could invite unnecessary risk, while careful Measured observation might mitigate it. The challenge lies in determining the appropriate threshold. With Atlas, we crossed it unknowingly. By probing its coma, transmitting radar signals, and disseminating our findings globally, we responded, irrespective of our intent. The lesson may be that responding is not a singular decision, but an ongoing process, interwoven into every act of exploration. The risk is not an isolated event, but a persistent condition, enduring as long as we direct our gaze outward. The cultural implications of this risk are substantial, shaping our self-perception and our place in the cosmos. Are we intrepid explorers, willing to answer any summons despite the danger? Or are we vigilant guardians, cautious and silent, apprehensive of exposure? Each identity possesses its allure, and each comes with a cost. Atlas compels us to confront this choice with unprecedented directness. Silence is no longer the default. Responding is no longer optional. Every anomaly, every visitor, every expression of curiosity becomes an element of the dialogue, whether we desire it or not. From another viewpoint, the peril inherent in responding might itself serve as the ultimate test. Perhaps entities like Atlas are not threats, but rather examiners. The anomaly serves as a chemical prompt. Our behavior is the response. Do we react with indiscriminate broadcasting or with meticulous study? Do we unite globally or fragment into suspicion and denial? The risks we undertake reveal our inherent nature, and it is this revelation that others may be seeking. The risk is not solely ours, it is mutual. For to issue a summons is also to expose oneself. In this sense, responding is reciprocal. Both parties face risks, and both await the other's actions. Ultimately, the dangers associated with responded calls cannot be eliminated, they can only be managed. Every scientific undertaking, every observation of visitors like Atlas, represents a miniature response. The challenge lies in determining the extent of our engagement, the degree of our revelation, and the boldness of our interaction. Perhaps silence is no longer feasible. Perhaps the call has already been answered. In that scenario, the sole remaining question is what will transpire next, and whether we are prepared for ramifications beyond our control. What if our transmissions were intercepted? This is the fundamental question underlying all discussions of SETI, extraterrestrial visitors, and the enigmatic silence of the cosmos. For decades, we have pondered the possibility of being heard. However, in the wake of celestial events such as Uma, Mua, Boris, and Atlas, a more profound consideration emerges. What if our signals, our broadcasts, our curious replies have already been received? What if somewhere within the galaxy, a record of humanity already exists, not as myth or imagination, but within the archives of another civilization? This prospect is disorienting because it compels us to shed our ingrained sense of isolation. We tend to assume that our transmissions dissipate into emptiness, scattered across the void. In reality, radio waves diminish, signals weaken, and distance erodes their energy. However, should advanced civilizations exist, their instruments may possess sensitivities, orders of magnitude greater than our own. What appears faint to us might be distinct to them. What we consider lost might be meticulously preserved. Our earliest broadcasts from the 20th century, music, speeches, military communications, may already be cataloged elsewhere. They might know us not through deliberate contact, but through the incidental leakage of our technology. In this regard, we have already been perceived. However, the advent of interstellar objects complicates this scenario. If Atlas or similar entities were intentionally sent, then our being heard is not a passive event, but an active one. Our reaction to these visitors, directing instruments towards them, bouncing radar off their surfaces, publicizing findings globally, becomes evidence of our awareness. They may already know that our atmosphere contains oxygen and that our planet radiates heat. What they could not ascertain until now is our capacity for observation. This shift is monumental. To be heard signifies more than mere detection. It denotes recognition as a sentient entity capable of recognition. Once this occurs, the relationship undergoes a permanent transformation. What if our transmissions were intercepted and our response was deemed reckless? Radar signals broadcast indiscriminately, curiosity unrestrained, exposure casual. Would another civilization interpret this as boldness or as naivete? Would they perceive us as promising or as a danger to ourselves and others? Hearing us might not equate to embracing us. It could signify an evaluation. And evaluations carry consequences. What if our transmissions were intercepted and our silence was instead noted? Perhaps Atlas contained anomalies specifically designed to elicit communication, yet we offered none. To us, this might represent caution. To them, it could signify refusal. What message does silence convey? Is it wisdom or apathy? Does it demonstrate discipline or imply indifference? In a universe where communication is fraught with peril, silence can function as both a shield and a barrier. If our silence was perceived after our transmissions were intercepted, we might have already been judged, even if we never become aware of it. The unsettling aspect is that being heard does not guarantee a response. Civilizations might archive our signals without revealing their presence. They may evaluate us without initiating contact. They might observe us for centuries, deliberating whether we pose a threat or whether we are worthy of engagement. Being heard does not equate to being answered. It could mean existing under observation, aware of possibilities, but perpetually uncertain. Silence might follow, not due to an absence of others, but because they have heard sufficient. If Atlas represented a summons and we responded, then a record of our reply may already exist. Perhaps instruments far beyond our comprehension captured the radar echoes we transmitted. Perhaps archives now contain a detailed map of our detection systems, a measurement of our patience, and a record of our caution and our recklessness. If so, then the act of hearing is complete. Humanity has already been cataloged. We may not yet perceive the repercussions, but the record has been established. The future will unfold with or without our awareness of its origin. The subsequent possibilities are vast. If we were heard by a civilization possessing greater age and wisdom, they might await our readiness. If we were heard by a civilization characterized by caution and fear, they might indefinitely avoid us. If we were heard by a civilization that is hostile or competitive, the risks escalate considerably. Nevertheless, the disquieting truth is that we cannot control interpretation. We can dictate what we transmit, but not how it is understood. Once heard, we cease to be the authors of our narrative. We become characters in someone else's. History offers further parallels. When isolated human cultures on Earth first came to the attention of others, their destinies were rarely within their own control. At times they were disregarded, allowed to develop unhindered. At other times, they were exploited, reshaped, and even eradicated. The divergence in outcomes often depended less on their actions and more on how they were perceived. The same may now be true for us. If we have been heard, then the perception of others will shape our future more profoundly than our own intentions. This imbalance represents the most unsettling risk of all. However, being heard might not be a threat but an opportunity. If we were heard by a benevolent intelligence, then our existence is already recognized, our presence acknowledged, and our awareness confirmed. Silence might not signify rejection, but rather patience. They might await our attainment of thresholds related to stability, unity, or maturity. Being heard could place us under observation, not for detrimental purposes, but for guidance. Perhaps the summons of Atlas was not a lure or a trap, but an invitation, one that will remain accessible until we are prepared to accept it. Even if no intelligence is behind Atlas, the fact remains that our actions reverberate outward. We are heard by the universe itself, if not by other intelligences. Every transmission, every spacecraft, every artifact on the moon or Mars serves as a testament to our existence. To be heard is to be inscribed into the cosmos. Our challenge is to determine the message we wish that record to convey. Will it be one of reckless curiosity, of cautious silence, or something in between? Whatever we choose, it will define us long after our departure. Being heard is not a choice. It is an inherent condition of technological advancement. The question is not whether, but how. And so we return to the initial inquiry. What if we were heard? The answer is that we likely already have been. Through radio leakage, atmospheric signatures, and our responses to interstellar visitors, humanity has already communicated. Whether anyone has listened remains beyond our knowledge. Whether anyone has judged is beyond our control. But we cannot undo what has been done. We are now a participant in the conversation, whether we wish to be or not. The sole uncertainty lies in what will follow, and whether enduring silence signifies absence or a prelude to a reply.